Hello there, and welcome to the Sleep Umentary channel. You made it here. Whatever the day asked of you, it can set itself down now. Let your shoulders loosen, let your breath find an easy rhythm, and imagine yourself far from streetlights and screens out where the road narrows to a ribbon of gravel, where crickets keep time and the air carries the clean scent of grass. You lie back on a worn blanket that still remembers picnics and summer heat. The ground is cool, steady, uncomplicated. Above you, the sky opens like a quiet lake of ink. If you let your eyes soften, a pale river appears grainy, luminous, and patient arching from one horizon to the other. We give it a single name, the Milky Way. But tonight you don't need to memorize anything. You only need to drift. So before we continue, hit like and subscribe so you don't miss a single revelation as this story unfolds moment by moment in real time. Tell me in the comments where you're watching, from what time it is there, and whether you believe we're hearing the whole truth about what's unfolding above our heads. And if you want to keep the signal alive, share this video on X, Facebook, Reddit, or even just with the people who still look up at night. You are the reason we can keep following the impossible, and for that, thank you. Your breath slows, and with it the thoughts that peck and flutter. One by one they fold their wings. In the stillness that remains, you notice how the galaxy is neither a picture nor a map, but a presence. Not a flat postcard of stars, but a living swirl of matter, gravity and time, a spiral with a mind for memory. Somewhere in there is your street, your window, the cup by your bed. Somewhere in there rests the iron in your blood and the calcium in your bones, forged in fires older than every story you've ever heard. You are not apart from this. You're threaded into it, a small warmth inside a larger one. If you could rise just a little above the fields, over the dark hedges and the drowsy barns, you might expect to see the galaxy like those textbook photographs, a pinwheel, neat and perfectly framed. But our home doesn't grant us that balcony view. We live inside the disk itself, as if tucked between the pages of a vast half-open book. From within, the spiral becomes a band thick, where we look along the page, thin where we peer across it. Dust and distant lights stack up along our line of sight, blurring at the edges, turning the night into a gentle smear of silver. What you see is a cross-section, a sideways slice of something much larger. This limitation isn't a flaw, it is an invitation. It asks you to imagine, to feel the shape from the currents passing through you. So let's imagine. Feel your breath as a tide. On each exhale, the day's noise recedes. On each inhale, the stars seem closer. The galaxy is not a solid wheel. It is a slow dance of patterns. The spiral arms are like traffic jams of starlight places where matter crowds slightly, and new suns flicker into being. Between those arms is space for rest, for quiet. Our sun and its family drift through this pattern like a boat through a long, shallow swell, rising and falling in and out, never truly still yet rarely hurried. Imagine the sun as a steady lantern, your lantern moving on a path that takes hundreds of millions of years to circle the center once. Imagine how patient the night must be to measure time like that. You remain on the blanket, but in your mind you begin to float the way you do just before sleep. The grass becomes a shadow, the shadow becomes a shore, and that pale river overhead becomes a road. Even from here you can sense the textures, the bright knots where clusters shine like handfuls of ice, the soft lanes of darkness, where dust veils hide newborn stars, the faint grainy spray of the farthest lights, old and thin and stubbornly present. If you listen, truly listen, you might notice there's a kind of hush inside the hush, an impression that the darkness is not empty. It is full of fields you cannot see, hydrogen clouds the size of nations, magnetic threads that would not lift a paperclip yet shepherd dust for light years, and the invisible pull of a kind of matter that neither gleams nor glows, but holds the whole structure together like a scaffold you can't touch. We call it dark matter because the name is all we can reach, but its work is the difference between a galaxy and a scattering. You shift slightly, feel the earth against your shoulder blade, count a few breaths the way you count waves. Somewhere toward the constellation Sagittarius, behind curtains of dust so thick that visible light drowns in them, the galaxy keeps a secret, a mass so compact and patient that stars slingshot around it like comets, tracing ellipses that only very precise eyes can see. We call it a black hole, and this one, our central one, sleeps more often than it feeds. It is not a mouth, but a metronome marking the heartbeat of the core. It reminds you that even the center of things can be quiet. You don't need to understand equations to feel that truth settle like a blanket over your chest. A breeze passes. The tall grass rustles like whispers from far tables in a cafe. You notice something small, the way your eyes keep adjusting, finding more stars the longer you look. This is how learning works too. The longer we give something our attention, the more it returns the favour. Astronomers use instruments to stretch that attention beyond what pupils can hold, radio dishes that hear the cold breath of hydrogen infrared telescopes that see through dust satellites that measure the tiny steady motion of billions of stars to reveal the galaxy's skeleton. But the first instrument is always the same one you're using right now, the willingness to lie still and let the night become specific. There's comfort in knowing we don't see everything. It means there is room for surprise. It means the world can be kinder than the headlines, richer than the routines. Somewhere in this river of light, stars are being born with a cry we cannot hear, and elsewhere older stars are returning their metals to the dark to be used again. The Milky Way is not a museum, it is a workshop. It is a kitchen that never closes. The recipe hasn't changed in billions of years, but the flavours keep shifting. Every element, every orbit, a variation on a theme that makes room for you. Think about the distance between your breath and the next one. It's small, almost nothing. Now think about the distance between one star and the next, a gulf so wide that even light takes years to cross it. Yet across those gulfs, gravity threads a net and time does the slow stitching, and somehow the result is something legible. Arms, bars, clusters, streams, all the shapes our minds love to find. We tell ourselves the galaxy is beautiful, and it is, but beauty is only the first word for what the night is trying to say. The longer we listen, the more the message sounds familiar, like something we've always known, that we are temporary and that we belong, that we are small and still enough, that every bright thing is born from a dark shelter, and every dark shelter given time gives rise to bright things. The blanket warms beneath you. Your body grows heavier, but your mind grows lighter, as if the gravitational pull of worry has slackened a little. And there in the lazy arch of the Milky Way you can choose the simplest kind of trust that you do not have to hold the galaxy together. It can spin without your effort. Your only work is to notice it, and to let the noticing dissolve into rest. The stars do not require you to be impressive. They invite you to be porous, to let light pass through the mesh of thought and into somewhere quieter. Before your eyelids fall, tuck away one last image, not of a perfect spiral seen from outside, but of this band as you see it now. Grainy and alive, proof that from inside the story the edges blur, and that is all right. We are within the disc inside the page, reading along the lines instead of looking at the cover. The book is thick and the chapters are long. Tonight you have begun at the beginning, not of the universe, not of the galaxy, but of this gentle journey through both. Take one more breath. Let the river of light do what rivers do. It carries, you float. And in that floating the day loosens its last knot and slips quietly into the dark. The night deepens, and with it your sense of stillness. You're no longer lying on the blanket, you're gliding, now weightless, through a faint haze of starlight that curves in every direction. Ahead, the Milky Way stretches like a vast glowing river seen from within its current. It looks peaceful, almost eternal. But the peace is misleading. Beneath the quiet, the galaxy hides an appetite. Every spiral, every halo of light you see above farm fields or city roofs is not a single creation, but a layered inheritance, a survivor of countless cosmic meals. The Milky Way, for all its beauty, is a cannibal. It has been eating smaller galaxies for almost as long as it has existed. The stars we call our own are in truth the scattered bones of others. Astronomers call this process hierarchical assembly, a slow gravitational feasting that built the modern universe. In the beginning, after the Big Bang cooled into its first thin fogs of hydrogen and helium, small galaxies bloomed everywhere like sparks in mist. Each one was modest, a few million stars drifting together, barely heavy enough to hold themselves intact. But gravity favors the large. Over time, these small galaxies collided, merged, and devoured one another, forming ever bigger structures. Galaxies did not grow like trees from seed to trunk. They grew like storms, swallowing other storms. Our Milky Way is one such storm. Its disk, its halo, its glowing bulge at the center, all were shaped by this long banquet. You might imagine that a galactic collision would be a single moment of violence, a flash, a crash, a cosmic explosion. But it isn't. It's more like an embrace that lasts for billions of years. Two galaxies drift close, their dark matter halos touch first, like invisible oceans meeting at their edges. Gravity begins to pull, stretching each galaxy into luminous ribbons. Stars far too small to collide directly are slung into long tidal streams, their orbits reshaped, their homes unmade. One galaxy may be torn apart completely, its stars scattered into the halo of the larger one where they continue to orbit forever as ghosts. Right now, as you drift through thought and sleep, the Milky Way is mid-bite. Out beyond the bright clutter of the inner disk, the Sagittarius dwarf galaxy is being slowly unraveled. Once a proud, compact spiral of its own, it has crossed our path again and again, each pass stripping more of its stars away. Some of those stars now move through our skies, mixed invisibly with native ones. If you look towards Sagittarius tonight, you are looking not just at a constellation, but at a wound still healing, a faint scar of light that arcs across our galaxy like a memory. And the Sagittarius dwarf is not the first. Before it, long before Earth existed, another small galaxy named Gaia Enceladus plunged into the Milky Way's side. That impact churned the early disk, thickened it, and may have created the dense bulge at the center. When astronomers map the motions of old halo stars, they find traces of this ancient invasion, streams of orbits looping against the main galactic flow, like eddies left by a ship that passed eons ago. Each captured star is a survivor of that collision, an immigrant whose home no longer exists. In the galactic night, destruction and creation are inseparable. When a small galaxy is devoured, its gas hydrogen, and helium mostly is drawn into the larger system where it fuels the birth of new stars. The old feeds the young, the past becomes light again. Even the violence is patient. The gravitational pull that tears one galaxy apart also spreads its gifts widely, ensuring that no matter is lost, only rearranged. If you could speed up time and watch from above, you would see galaxies merge and blend like clouds, their luminous centers weaving together, their spiral arms dissolving into one another until a new shape, larger, calmer, emerges from the storm. This is the cosmic rhythm of rebirth galaxies consuming galaxies' matter, recycling matter. In the process, the Milky Way has become a patchwork of ancestry. Its outer halo is full of foreign stars, metal. Poor ancient, drifting in long tilted orbits that never quite match the native pattern. Its inner disk is a quilt sewn from the remains of dozens of smaller systems stitched together by time and gravity. Even the sun may carry in its motion a whisper of those ancient collisions, a slight tilt, a drift inherited from some forgotten merger billions of years before our planet cooled. If this sounds brutal, remember every stable structure in the universe is born of imbalance. Without collapse, there is no shape. Without consumption, no growth. The stars above you tonight shine because clouds of gas once fell inward, surrendering to gravity's pull, heating, igniting, becoming light. On larger scales, galaxies follow the same rule. Each act of devouring is also an act of creation, each loss a rearrangement of possibility. Astronomers see this history written in the chemistry of stars. When they analyze the light from distant suns, they can tell where those stars were likely born, what elements they contain, how much iron, how little magnesium, which ratios whisper of alien origins. The Milky Way's stars do not speak one language but many. Some are rich in metals, children of later, more complex generations. Others are nearly pure hydrogen and helium, ancient voices from the first epochs of starbirth. Together they form a chorus, a song of assembly that spans 13 billion years. When you think of our galaxy, now try not to picture a single organism perfect and still, but a living archive, an autobiography written in collisions. Imagine a tree that grows not by adding rings, but by absorbing other trees, each with its own roots and memories. Imagine that within its branches somewhere a tiny leaf called Earth trembles, unaware that the sap that nourishes it comes from countless vanished forests. That is the Milky Way. That is the inheritance we sleep inside. Far away beyond the galactic rim, other galaxies are doing the same. The cosmos is full of predators and heirs. In deep space surveys, astronomers have caught galaxies mid-meal dwarfs, being torn apart, their stars stretched into delicate bridges of light. It looks tragic, but it is the universe's most consistent act of mercy. Nothing is wasted. What is torn becomes part of something larger. As you breathe in, picture the Milky Way not as a tyrant, but as a caretaker, gathering lost wanderers, folding them into a wider rhythm. Every star in the sky has been moved, recycled, transformed. Even the darkness between them glows faintly with the scattered remains of what once was. You too are made of such remnants of carbon formed in older suns of calcium that once drifted through a dead star's wind. In a way, you are the galaxy's descendant, and its continuation proof that even destruction can be creative if given enough time. And so the story of the Milky Way begins not with birth, but with appetite, and with the quiet understanding that survival in this universe is an act of constant transformation. Galaxies do not live by resisting change, they live by swallowing it. Above you, the sky looks peaceful again. The river of stars stretches unchanged, yet within it, entire worlds are still being devoured, others being born from their remains. You are watching the aftermath of a billion-year feast, the calm after a cosmic storm that never truly ends. The galaxy that ate its ancestors hums softly overhead, and from that hum comes light, and from that light every story that will ever be told beneath it. If you stay still long enough beneath the night, a faint patch of haze rises above the tree line, just a blur smaller than your thumbnail held at arm's length. You might overlook it as a smudge on your glasses or a thin cloud crossing the stars, but that soft shimmer is another galaxy, the Andromeda. 2 million light-years away, yet bright enough to reach your eyes, unaided, a whisper of light that left its home before the first human-shaped fire. For now, Andromeda seems harmless, a quiet neighbour drifting in the dark. But the motion is not as calm as it looks. Through telescopes that measure the tiny tug of Doppler shift, astronomers have found that Andromeda is moving toward us fast, by galactic standards nearly 400 kilometers each second. Space itself expands, but on the scale of a few million light-years, gravity can still win. The Milky Way and Andromeda are falling toward one another, drawn together by their shared mass, by the unseen web of dark matter that links them like invisible roots underground. From the perspective of a single lifetime, nothing changes. Even 1,000 generations would see the same constellation pattern, Cassiopeia's crooked chair, Andromeda's faint ellipse. But if you could accelerate time press fast forward on the night sky, the story would unfold like an immense slow-motion film. Over the next billion years, Andromeda's faint smudge would grow sharper, spreading wings of light. By the time Earth completes another few galactic orbits, the patch will stretch wider than the moon. The spiral arms will unfurl across the heavens, a bridge of stars reaching toward us. The constellations, you know, Orion, Ursa, Major the Summer Triangle, will warp, dissolve, replaced by a new architecture of light. When the two galaxies finally touch roughly 4.5 billion years from now, the encounter will be nothing like the cataclysm our words imply. Galaxies are mostly emptiness. The stars themselves are so far apart that direct collisions are rare. You could take two spirals the size of dinner plates, place them on opposite sides of Earth, and the distance between their stars would still be vast compared to their size. The drama of a galactic merger is not one of impact, but of choreography. Their mutual gravity will twist both spirals into long ribbons, flinging arcs of stars into space. Great loops will curve outward, tidal tails gleaming like strands of silk. Each galaxy's dark matter halo will entangle with the others, pulling them together again and again until they can no longer be distinguished. Our sun, by then swollen and bright in its own old age, will likely migrate to a new orbit flung outward into the expanding halo of the merged system. Earth may have already been scorched beyond habitability, its oceans long boiled away. But if consciousness still exists somewhere, perhaps among other worlds, or within machines that remember this blue origin, it will watch the sky transform into a luminous whirlpool. The Milky Way and Andromeda will merge into a single enormous elliptical galaxy, sometimes called Milkomeda. Its heart will shine with two black holes spiraling together, radiating gravitational waves like ripples through the fabric of space-time. There is poetry in that slow inevitability. Every night you see Andromeda is a glimpse of destiny. The two great spirals have been partners in motion since they were born, bound not by romance but by physics, the most patient courtship in the universe. Each rotation of our sun around the galactic center brings us imperceptibly closer. It is a love story written in vectors and velocities measured not in years but in epochs. Imagine the view from some future shoreline on another surviving planet. Its inhabitants, whatever form they take, look up to see the sky filled with structure, vast arcs of stars, where once there were single points. The night no longer dark, but a canvas of motion, galactic tides glowing faintly, nebulae stretching in veils across half the firmament. The collision will take billions of years to settle, and during that time, the two populations of stars will mix their gases, igniting new generations of suns. It will be a cosmic renaissance born from ruin. From our tiny moment, it is almost impossible to feel the pace of such events. Human history fits into the first blink of this encounter. In the time it takes for a single rotation of Andromeda's spiral arm, species rise and vanish, civilizations bloom and fade, languages are born and lost. Our lifetimes are brief sparks compared to this gradual convergence. Yet in that brevity lies something comforting. We are witnessing a frame of a movie whose ending we can already imagine, even if we will never see it. So when you gaze toward that faint patch of haze again, remember it isn't just another galaxy. It's a mirror drifting slowly toward its reflection. The Milky Way and Andromeda are two halves of a future whole destined to collide, to blend, to begin again. Long after our nights have faded, their light will still be dancing. The universe, even in its grandest collisions, never hurries. It only continues. High above the crowded disk of the Milky Way, where the starlight thins into cold dark space, a few lonely suns wander. They drift on long tilted paths that never touch the spiral arms, ancient travellers circling far from the galactic plane. Some of them are so old that in a way they don't truly belong here. They were born before the Milky Way was even finished being born. Astronomers call them metal-poor stars. In cosmic language, metal doesn't mean iron or gold alone. It means every element heavier than hydrogen and helium. The universe began with almost nothing else, just those two simplest atoms, forged in the first minutes after the Big Bang. The heavier elements came later inside the cores of the first generation of massive stars and in the explosions that marked their deaths. Each new star inherited the ashes of its ancestors. So the more metals a star contains, the younger it is in the universal story. The most ancient ones are nearly pure light, so old it carries the chemical silence of the early cosmos. To find these elders, astronomers use a kind of stellar genealogy. They spread a star's light into a spectrum, a band of colours, that hides within it a pattern of tiny dark lines. Each line marks an element absorbing light at a specific wavelength. Iron leaves one signature, magnesium another, calcium another still. It's as if every star speaks in its own dialect, written not in sound but in light. With powerful spectrographs, scientists read these patterns like fingerprints tracing a star's lineage across billions of years. The older stars show almost no lines beyond hydrogen and helium, a sign they were formed when the universe itself was young and raw. Some of these relics have been found within the Milky Way's halo, orbiting far above the disk, like sentinels of deep time. One known as SMSS J03136708 contains less than 1/10,000th of the iron found in the Sun. That means it was born before iron was common, before supernovae had sown it widely through space. It's a direct descendant of the universe's first stars, which lived fast, died violently, and left their ashes to seed the next generation. When you look at such a star through a telescope, you're looking at a survivor of the universe's childhood, a faint ember from a fire that has long since gone out. These ancient halo stars move differently from the rest. While the Sun and its neighbours trace neat circles around the galactic centre, the old ones follow stretched looping orbits that dive in and out of the disk. Some move backward relative to the galaxy's spin, as if remembering the direction of an older dance. Their paths tell stories of past mergers, small galaxies consumed by the Milky Way long ago. Each foreign orbit, each strange trajectory is a clue to a forgotten event. Astronomers piece them together the way archaeologists study pottery shards, reconstructing civilizations that vanished eons before our planet formed. If you could stand on a world orbiting one of these old suns, the night sky would look sparse, almost empty. There would be fewer bright neighbours, more darkness between each light. The interstellar medium there would be thin and unpolluted, no heavy elements, no dust grains, no complex molecules drifting between stars. Planets like Earth would be impossible then. The raw materials for rock and water and life hadn't yet been made. These first suns burned in a universe that was still learning how to build complexity. They shone only briefly, lived fiercely, and when they died, they created the ingredients for everything that would follow. Every element that shapes our world, carbon in our cells, oxygen in our lungs, iron in our blood exists because earlier generations of stars forged them. Those old metal-poor stars are our great-grandparents in the cosmic family tree. The Milky Way itself is their descendant, a child of their debris. When you inhale, when your heart beats when you speak, you're using atoms that once lived inside stars far older than our galaxy. There is something human in the way we search for them. We've always looked backward, trying to find our beginnings in something larger, in myths, in fossils, in family stories whispered through generations. The astronomer's telescope is an extension of that same impulse, a desire to trace the light of memory back to its first spark. When they measure the faint iron line in an ancient star's spectrum, they're reading a record written before time had calendars. The instruments may be modern, but the motive is timeless to know where we came from. Imagine for a moment that you could compress the Milky Way's entire history into a single year. The galaxy would form in January. The sun wouldn't appear until early September. Earth's dinosaurs would walk for a few late autumn days. Humanity would blink into existence a few seconds before midnight on December 31st. Yet those halo stars, the ancient ones, would already be there when the year began, older than the calendar itself, older than the idea of counting. Their endurance is humbling. They burn slowly, conserving their fuel across eons, their surfaces cool and steady. They have witnessed galaxies colliding, spiral arms forming black holes, waking and sleeping again. While everything else changes, continents shifting, civilizations rising and falling, these stars remain turning quietly above the galactic plane patient as stones. When you look up tonight, you won't see them with your naked eye. They're too faint, too distant. But they are there, circling the Milky Way like beads on a loose thread. Their light still crosses space toward us, carrying messages older than our world. Somewhere out there amid the silent dark are suns that have seen the universe go from fire to structure, from chaos to calm. And within their pale light lies a story we're still learning to read, the story of how a cosmos without metals, without planets, without life slowly built the possibility of all three. We too are the continuation of that slow creation. The same atoms that once drifted in those early stars now whisper in our neurons and pulse through our hearts. When you think about ancestry, think wider. The line does not stop with human families nor with Earth itself. It stretches all the way back to the first lights that burned when the universe was young. So the next time you gaze into the night sky, remember that somewhere out there are stars older than the galaxy they now call home, elders adrift in a spiral built from their ashes. They are the memory of the cosmos, the first storytellers of light, and in the quiet between breaths, if you listen carefully, you might almost hear them still speaking. If you could step outside the galaxy and watch from afar, you'd see our sun tracing a long patient circle through the Milky Way's spiral arms, a small ember riding the rim of a colossal wheel. That circle is not a journey you can mark on a calendar. It is too large for days or years. It takes the sun about 225 million Earth years to make a single orbit around the galactic center. Astronomers call this vast circuit a galactic year. One galactic year ago, there were no humans, no continents as we know them, not even dinosaurs. The last time our solar system was in its current position, the great extinction at the end of the Permian had just unfolded, and life on Earth was starting over from near zero. 250 million years later, we are back in roughly the same place on that track, 20 galactic years into the Sun's life, about halfway through its journey around the Milky Way for the 20th time. Imagine compressing that motion into a single human scale, one galactic year as a single day. The dinosaurs would dominate the early afternoon, the first mammals would appear near sunset, and modern humans would arrive in the last split second before midnight. From this perspective, everything we call history has happened in the blink between one heartbeat and the next. The sun moves at astonishing speed, about 230 kilometers per second, yet the distance to travel is so immense that progress is invisible. In the time it takes you to breathe, we've already moved hundreds of kilometers through space, and still even at that speed, one orbit takes longer than all recorded biological history. As we drift, the view slowly changes, constellations reshuffle, new spiral arms come and go, and the neighborhood of stars around us is replaced every few million years. The sky of the dinosaurs was not the same sky we see now, and the sky of whoever comes next will not be ours. Each galactic year writes a chapter of Earth's geological story. When the sun last crossed the region we occupy now, continents were fused into the supercontinent Pangaea, a single landmass surrounded by an endless ocean. As we travelled along the galactic path, that continent cracked apart. The Atlantic opened. Mountains rose where seas had been. The very crust of the planet bears the rhythm of our orbit through the galaxy. Some scientists have wondered whether cosmic events along our route, supernovae nearby star-forming regions, clouds of interstellar dust, might have influenced Earth's climate or even the pace of evolution. Perhaps each chapter of life's drama unfolded under a slightly different sky, illuminated by different cosmic neighbours. Picture it 20 times around the Milky Way since the sun first ignited. During the first few orbits, our solar system was still gathering its planets. Later orbits carried the first algae, then the slow build of oxygen that turned the atmosphere blue. Several orbits later, fish learned to walk. Forests spread, reptiles filled the land. With each revolution, Earth changed, costume rearranged, its continents rewrote its climate. And through it all, the sun continued its patient glide, the same steady lantern, carrying its little family of worlds through the spiral's shifting lanes. It's easy to think of the galaxy as still like a backdrop for our stories. But it is we who are the motion, the caravan of planets, asteroids, dust and light moving along a road too immense to see. The stars you recognize in the constellations are only temporary companions, fellow travelers sharing this portion of the orbit. A few tens of millions of years from now, new patterns will grace the night. Orion will dissolve, the Big Dipper will unhook its handle, and other shapes will take their place. The sky is not permanent, it's a moving mural painted on a turning wheel. Every revolution around the galaxy leaves traces in our rocks and fossils. When the sun was opposite its current position deep in another spiral arm, mammals had only just appeared, tiny and nocturnal. Half a galactic year later, as we approached where we are now, those mammals had become apes, walking upright on the African savannas. Each lap corresponds to eras of unimaginable change, oceans opening and closing, species emerging and vanishing, the rise and fall of mountains and empires alike. And yet, despite all that transformation, the sun's path is steady. It orbits the galactic center at a distance of roughly 26,000 light-years, neither plunging inward nor escaping outward. We ride that orbit inside a quiet lane between major spiral arms. A region scientists call the Orion Spur a peaceful neighborhood, far from the violent core. Perhaps it's coincidence, perhaps it's fortune. In a busier part of the galaxy near supernovae and black holes, life might have struggled to survive. Here our system has enjoyed 4.5 billion years of relative calm, a cosmic cul-de-sac perfect for evolution to work undisturbed. If you could watch the Milky Way from above, the sun's path would look like a bright bead sliding around the rim of a vast whirlpool. 20 loops completed, tens more to come before the sun's fuel runs low and it swells into a red giant. By then, the galaxy will be different again, reshaped by collisions and mergers, its spiral arms rearranged. But the memory of those revolutions will remain written in the isotopes of meteorites, in the sediments of ancient seas, in the delicate structures of DNA that record the story of survival. When you stand outside on a quiet night, you can imagine the ground beneath you moving not only around the sun, but with the sun through space along this immense orbit. Each breath you take happens in a slightly new part of the galaxy. The air itself has never been here before. The Milky Way does not hurry. It turns slowly and inexorably, like a clock too vast for hands or numbers. Every moment of your life fits within a fraction of a second on that cosmic clock, and yet that second matters. It is your share of the great rotation, the proof that you too are part of the motion that shapes everything from the drifting continents to the curve of the stars. So the next time you feel still, remember you are not. None of us are. We're all passengers aboard a world in orbit around a star in orbit around a galaxy that never stops circling. The night sky above you is the wake of our motion, the trail of a ship that has been sailing for billions of years. From a distance, the Milky Way looks complete, a grand spiral glowing with age and confidence, as if its story were already written. But galaxies, like cities, are never finished. They grow, collapse, and rebuild themselves through unseen exchanges. Even now, our galaxy is expanding its reach, gathering fresh material from the dark around it. It is in the truest sense still becoming. In the space between galaxies stretches an ocean of near-nothingness, hydrogen, atoms so sparse that a cubic meter might contain just a handful. And yet that emptiness is not idle. Thin filaments of gas thread through it, forming part of a vast cosmic web, the hidden architecture of the universe. Along those filaments, matter flows like trade routes between cities, feeding galaxies quietly across billions of years. The Milky Way drinks from this web constantly. Invisible rivers of hydrogen fall inward, replenishing the fuel that stars require. Astronomers call this steady infall galactic accretion. The process is subtle streams of gas too diffuse to see invisible light slide through the halo, gradually joining the disk. As they spiral in, gravity compresses the gas into clouds, and from those clouds, new stars are born. It's the cosmic equivalent of cargo ships arriving at a port each night, delivering raw material to factories that never stop working. From afar, it looks peaceful. But each droplet of gas is a tiny note in the galaxy's continuous symphony of renewal. Even darker forms of matter join this traffic. Around the luminous disk lies an enormous halo of dark matter, a vast sphere of invisible substance that outweighs all the galaxy's stars combined. We don't know what it is made of. It neither shines nor absorbs light, yet its gravity shapes everything we see. Dark matter acts like a quiet landlord of cosmic real estate, drawing in gas, shepherding stars, deciding where galaxies will form and how large they can grow. Without it, the Milky Way's outer edges would spin apart like sparks from a wheel. Imagine the galaxy as a city seen from orbit at night. The spiral arms are its highways bright with traffic. The central bulge glows like a dense downtown core where energy and mass crowd together. The halo, mostly unseen, is the rural expanse that supplies it all fields of unseen gravity feeding the lights below. And the cosmic web beyond that is the intergalactic road network, linking one metropolis of stars to another. Hydrogen moves along those filaments the way ancient caravans carried grain metals and ideas between civilizations. Each arrival keeps the city alive. But growth always comes with a price. The Milky Way consumes its resources, slowly converting gas into stars faster than the universe can replace it. Its current star formation rate, about 1 or 2 suns per year, is modest compared to its youth, when hundreds of stars were born every day. It's as though our galactic city has matured its boom years behind it, now focused on maintenance rather than expansion. The luminous towers are still rising, but at a more deliberate pace, and yet the inflow continues. Around the edges of the disk, astronomers have discovered immense reservoirs of cool hydrogen, some left over from ancient collisions, others freshly arriving from intergalactic space. These clouds drift like weather fronts, hundreds of light years across, some destined to merge with the disk and ignite new star-forming regions. Others may fall apart before reaching the core, scattering their atoms back into the halo, where they'll wait to be gathered again. The galaxy's economy is circular. Nothing is truly lost. Even the dark matter halo is evolving. Computer simulations show that it isn't smooth, but clumpy, containing countless small knots, miniature halos, that may be the remains of dwarf galaxies long devoured. They orbit like silent satellites, their gravity stirring the disk and shaping the faint warp we can detect in radio waves. The Milky Way's outermost structure is thus not static, but alive with motion, a busy periphery echoing with invisible tides. There is humility in realizing how dynamic our home remains. While we worry about the lifespan of civilizations measured in centuries, the galaxy is running an economy of creation and destruction that spans billions of years. Each star you see tonight is part of that accounting, some newly added to the ledger, others already nearing their end. In the balance between gain and loss, the Milky Way persists. Think of it again as a city, its lights representing stars, its traffic the movement of gas and dust, its skyline reshaped by unseen planners. Some neighborhoods are ancient globular clusters of old suns that burn with quiet dignity. Others are construction zones full of collapsing gas and newborn stars still wrapped in their dust. Above it all hangs the halo, an invisible governance of gravity keeping order, even as it allows the city to sprawl ever outward. And beyond our borders lie other cities, Andromeda Triangulum, the small and large Magellanic Clouds, connected by the same network of cosmic roads. Their interactions with us send ripples through space, subtle distortions in the Milky Way's outer rim. Each encounter brings new material, new stories, new mergers waiting to happen. The galaxy's future expansion is already being negotiated in the dark across distances too large for light to bridge quickly. When you close your eyes tonight, imagine that traffic still flowing cold gas threading through intergalactic space, drawn toward our spiral arms by the promise of gravity and transformation. The Milky Way, far from static, is a living city in the dark, its borders porous, its appetite endless. We may think of our galaxy as old and settled, but it's still building itself, still taking deliveries from the cosmos. Somewhere in those incoming streams are the atoms that will one day light new stars, form new worlds, perhaps even breathe through new lungs. The city of stars never sleeps. It only shifts its glow from one district to another, trading darkness, for light century after century, forever expanding into the quiet beyond. From within the Milky Way, the view is both magnificent and deceiving. We see its glow spilling across the night sky like a white ribbon, dense, luminous, infinite, and yet what we see is only the faintest suggestion of its shape. For all our telescopes and equations, we still don't know exactly how many arms our galaxy has, how far they reach, or how they twist into the dark. We live inside the mystery we're trying to measure. If you could stand far beyond the spiral, perhaps in another galaxy, the Milky Way might appear like those photographs in astronomy textbooks, a clean, symmetrical whirlpool of light, a cosmic seashell spinning in silence. But from our position, buried deep inside the disk, we are like sailors trying to map an ocean while drifting on its surface. The waves are all around us, the horizon curves endlessly, and every measurement is clouded by distance and haze. The first explorers of our galaxy were just as patient and uncertain as the mariners who charted the Earth. In the 18th century, William Herschel and his sister Caroline made one of the earliest attempts to map the Milky Way by counting stars. They imagined that more stars in a direction meant more galaxy that way. Through their telescopes, they found the sky thickened towards Sagittarius, thinning in the opposite direction. From that, they inferred a flattened structure, a disk with the sun near its center. They were half right. The idea was revolutionary for its time, yet it took another 100 years and far more powerful instruments to realize we were not at the center at all, but adrift near the edge of one arm among many. Today, radio telescopes trace clouds of cold hydrogen gas that outline the galaxy's shape in long spirals. Infrared observatories peer through the dust that blocks visible light, revealing hidden clusters and lanes of stars. But even now, the picture remains incomplete. Some studies suggest 4 major spiral arms. Others find only 2 with smaller branches winding off them. What we thought were continuous curves sometimes break into fragments. Some fade abruptly, others reappear in unexpected places, crossing like braided rivers. The Milky Way may not be the neat pinwheel of popular imagination, but a living asymmetrical swirl changing with every new discovery. The main reason for this uncertainty is dust, tiny grains of carbon, silicate and ice that float between the stars, dimming and reddening their light. To visible telescopes, dust is opaque. It builds curtains that conceal the galaxy's heart. Even the most powerful optical instruments cannot pierce the thick lanes that slice across the sky. But to radio and infrared eyes, those same curtains become translucent. Astronomers use these wavelengths like sonar, sending invisible signals through the dark to detect what lies beyond. Slowly, year after year, a clearer outline emerges, though never perfectly. There will always be shadows we cannot lift, horizons we cannot quite reach. In that sense, we're not so different from the early explorers who set sail across uncharted seas. They too relied on indirect clues, the colour of water, the flight of birds, the pattern of waves to guess what land might lie ahead. Their maps were beautiful but flawed, full of dragons and blank spaces labelled, "Here be monsters." Our galactic maps are the same, though our dragons are made of plasma and dark matter. We fill the unknown with imagination because we must, and maybe that uncertainty is a gift. To know everything about the galaxy would be to flatten it to make it ordinary. The mystery keeps us humble. It reminds us that even after centuries of looking up, we still inhabit a frontier as vast as any the sailors of old could dream of. Every new telescope is a ship leaving port, every beam of data a compass needle trembling toward discovery. Picture the Milky Way not as a static diagram, but as an unfolding story, a manuscript written in light and shadow. Dust clouds are its punctuation marks, pauses where meaning hides for a while before revealing itself. Spiral arms are its sentences curling around the center, repeating themes, echoing phrases. Somewhere between those lines we live a brief word in a paragraph still being written. When the James Webb Space Telescope looks through that dust, or when the Gaia mission measures the motion of 1 billion stars, we're continuing the same act of curiosity that once drew ancient navigators to the sea. They had no satellites, no global charts, only the courage to follow faint stars across an endless horizon. We too are following stars, though ours are far older and farther still. In a way, the galaxy protects its secrets on purpose. It lets us see just enough to stay curious, but never enough to feel finished. That veil of dust, that distance, that distortion, they are not obstacles, but invitations. They remind us that discovery is not a destination, but a practice, a rhythm, a conversation with the unknown. So when you look up and see that soft milky streak crossing the sky, remember how little of it is truly visible. You are seeing the faint shimmer of a structure too vast to comprehend, traced by stars you will never visit, shaped by forces you can only sense. We are map makers without a vantage point, explorers drawing coastlines from the motion of waves, And yet with every observation, every refinement, our picture of home grows sharper. The Milky Way is still teaching us to see, and perhaps that is enough that the galaxy remains partly hidden, a reminder that the cosmos, like the human heart, always keeps something back, something worth reaching for. Somewhere in the deep outskirts of the galaxy, far beyond the spiral arms, a single star streaks through the dark like a lost ember blown from a fire. It moves faster than any companion around it, so fast that the Milky Way can no longer hold it. Its path is straight, its purpose simple. Outward, always outward into the quiet between galaxies. Astronomers call them hypervelocity stars. Rare suns hurled from their homes at speeds of 1,000,000 kilometers per hour or more. They are the exiles of the cosmos traveling too quickly to ever return. The galaxy, vast as it is, cannot keep them. In a universe defined by gravity, these few have broken free. The first of them was discovered in 2005, a small blue star catalogued as SDSS, J090745-0245507. When scientists measured its motion, they found it racing away from the galactic center at nearly 2.5 million kilometers per hour, fast enough to escape the Milky Way entirely. Since then, dozens more have been found, each with its own strange trajectory. Some are massive and hot, shining with defiant brilliance as they rush through intergalactic space. Others are faint, aging suns carrying their quiet light toward the cold beyond. How do they achieve such impossible speed? The most dramatic launches happen near the galaxy's heart, where the supermassive black hole, Sagittarius A, sits like a hidden slingshot. Many stars live there in pairs, orbiting one another in a delicate dance. When such a binary system strays too close to the black hole, gravity tears it apart. One star is captured, pulled inward until it vanishes. The other is flung outward at incredible velocity, hurled into the galaxy's halo like a stone skipped from a giant's hand. In an instant, a quiet companion becomes a wanderer bound for eternity. There are gentler ejections too. Supernova explosions can hurl their surviving partner stars away when one member of a binary detonates. Three-body interactions within dense clusters can fling stars from the core like marbles colliding in zero gravity. But the most extreme speeds come from the black hole's tidal grasp. Sagittarius A is not only the Milky Way's anchor, it is also its catapult. These exiled stars travel immense distances. In just 1,000,000 years, a hypervelocity star can move farther than the Sun has drifted in its entire lifetime. Some already lie near the galaxy's edge 100,000 light-years from home. Others have slipped beyond our gravitational reach, entirely crossing into intergalactic night. Out there they shine alone, tiny lighthouses adrift between cosmic shores. They will continue to burn for millions, even billions of years, their light growing fainter as they travel until only the silence of space remains. To imagine their journey is to feel something deeply human. We too are creatures of orbit, of community, of gravitational ties that define our belonging. But sometimes in every story something breaks away. Freedom and exile are twin forces, both born from release. The rogue star is lonely, yes, but also free of every pattern. It has escaped the pull that binds everything else. It will never circle back. It will never be caught. Its light is a message from a life untethered, streaking across an emptiness so large it makes language falter. Astronomers track these travelers not only for their poetry, but for what they reveal. Their motion helps us measure the Milky Way's mass. To fling a star free, the galaxy must have exerted a certain gravity first. The faster the escape, the deeper the well that launched it. By studying their velocities, scientists trace the unseen distribution of dark matter, the invisible skeleton of the galaxy's pull. Even in leaving the exiles tell us something about the home they've left behind. Some of these runaway stars carry their own small systems, planets, or remnants orbiting them, swept along for the ride. Imagine such a world circling a sun that no longer belongs to any galaxy. Night after night, its sky would be almost empty, the familiar band of the Milky Way reduced to a faint streak behind it, shrinking with each passing century. No neighbouring constellations, no galactic sunrise, only the dim haze of distant clusters glimmering like memory. If life somehow existed there, its stories of home would be whispers about a place it could never see again. And yet there is a kind of peace in that isolation. Freed from the noise of gravitational crowds, the rogue star sails through time in perfect solitude. It will not collide, will not be disturbed, will not be pulled back into any orbit. It moves forever through a universe that neither hurries nor hesitates. Its freedom is its destiny, its loneliness, the cost of motion, Here on Earth we live bound to our sun, which in turn is bound to the galaxy, which itself is bound within the local group, a chain of gravitational relationships that stretches across eternity. But somewhere out there the exiles travel alone, and in their long unwavering paths we can read something both cosmic and intimate, that even in a universe governed by attraction, there are moments when something lets go and chooses the open dark. They are rare, these rogue suns, but real. A few are already beyond the halo, their light still travelling toward us from 1,000,000 years ago, telling of a moment when gravity lost its hold. Their brilliance is faint, but unmistakable small scars of light against the deep. They remind us that every system, no matter how vast, contains the possibility of escape. So the next time you look into the sky, imagine one of them passing silently beyond the edge of vision, a single spark against infinity carrying the memory of a galaxy it will never see again. A wanderer with no map, no destination, only motion, and in that motion, a quiet, eternal grace. In the slow turning of the Milky Way, not every star moves with the tide. Most follow the same direction around the galactic centre, keeping a quiet rhythm that has lasted for billions of years. But here and there, scattered like notes played in reverse, some stars move against the current. They circle the opposite way, crossing the flow of the spiral like lone dancers ignoring the music. Astronomers call these retrograde orbits. They are rare, and they should not exist if the Milky Way were born in perfect isolation. A galaxy forming from a single cloud of spinning gas produces stars that all inherit the same direction of rotation, like the synchronized spin of a hurricane. So when we find stars moving backward, they are anomalies, fossils of disruption, evidence that the Milky Way is not a single story, but an anthology of many. These backward-moving stars are survivors of ancient mergers, remnants of small galaxies swallowed by ours long ago. When one of those galaxies was captured by the Milky Way's gravity, its stars didn't instantly conform to their new home's spin. They kept their old paths like travelers, clinging to familiar roads even after crossing a border. Some were absorbed into the halo, looping far above and below the disk. Others blended into the thick disk itself, where their contrary motion still betrays them billions of years later. In this way, the galaxy remembers through movement. It carries its history not in writing or fossils, but in the direction of its stars. Astronomers can read that memory the way oceanographers read currents, watching for eddies that swirl differently, tracing where they began. With missions like Gaia, which measures the precise motions of over 1 billion stars, we can now map those subtle reversals across the sky. The data reveals long, ghostly streams arcing around the Milky Way stellar debris from ancient collisions, entire populations moving upstream through the galactic flow. One of the most famous of these is the Gaia Enceladus population, a vast structure of stars orbiting opposite to the Milky Way's main rotation. They are thought to be the remains of a dwarf galaxy that merged with ours about 10 billion years ago. When that smaller galaxy fell into the Milky Way, its stars scattered, spreading through the halo like pollen on a slow wind. Even now they carry that memory of impact, moving backward through the greater whirl. To visualize it, imagine standing beside a river during salmon season. Thousands of fish push upstream muscles, burning against the current, each one driven by instinct to return to its origin. The Milky Way's retrograde stars are like those salmon ancient travelers who remember where they came from, not through thought, but through motion itself. Their orbits are acts of memory, unconscious but precise, carrying the story of collisions that shaped the galaxy long before the sun was born. If you could see the Milky Way from above and colour every retrograde star red, while the rest stayed blue, you'd watch the pattern pulse and swirl, two populations mingling, but never quite blending. Blue streams flowing one way, red eddies swirling the other. The result would look less like a single spiral, and more like a living organism, veins of history circulating through its arms. These counter-rotating streams also help astronomers measure the timeline of our galaxy's growth. The ages and compositions of the backward stars reveal when and how the mergers happened. The metal-poor ones, older than most, tell of early collisions that built the halo. Younger retrogrades closer to the disk hint at, later in fall, smaller dwarfs drawn in over time. Each orbit becomes a clock hand marking a different chapter in the Milky Way's long autobiography. There's a quiet poetry in that idea that even when destruction erases a structure, motion remembers. Every revolution, every path through space is a sentence in the galaxy's diary, written not in words but in momentum. These are not static ruins like broken temples or fossilized bones. They are moving monuments alive and changing, yet still whispering of their origins. It also reminds us that harmony does not mean uniformity. The Milky Way is beautiful, not because every star obeys the same rule, but because it holds together difference without collapse. Retrograde orbits prove that discord can coexist with order, that the galaxy can accommodate memory and motion at once. In the quiet symmetry of its rotation, there are pockets of resistance, echoes of what came before refusing to be smoothed away. Somewhere among those contrarian stars might drift suns with planets of their own worlds moving backward through the galaxy, entire solar systems carrying their ancient momentum like secret luggage. If life exists there, its inhabitants would look up at a sky subtly different from ours, the constellations sliding in the opposite direction. For them, the galaxy itself would seem to turn the wrong way. And yet, in another sense, there is no wrong way, only inheritance. The salmon swim upstream because the river once taught them to. The stars orbit backward because a long-vanished galaxy set them spinning that way. Both are acts of remembrance carried forward through time. When you look at the Milky Way tonight and see its silver band stretching across the dark, think of the unseen traffic. Within it, billions of stars moving together, and a few thousands swimming against the tide. Their rebellion is gentle, almost invisible, but is also the reason the galaxy has texture, depth, and story. The universe does not keep its history in books or monuments. It keeps it in motion. And even in the stillness of night, the galaxy is writing each orbit a sentence, each reversal a footnote to everything that came before. Every night, the Milky Way appears calm, a luminous band draped across the sky, ancient and serene. But behind that stillness lies a record of collisions, the scars of cosmic meals the galaxy has long since digested. Its disk and halo are not seamless structures, but a mosaic of ghosts, the remnants of smaller galaxies that fell into the Milky Way's gravity and were slowly torn apart. The stars of those lost worlds are still here, scattered like ashes across the sky, moving along orbits that whisper their forgotten names. The most dramatic of these ancient mergers is known as Gaia Enceladus, sometimes called the Gaia sausage, for the long stretched shape of its star's orbits. It was once a dwarf galaxy, perhaps a tenth the size of the young Milky Way. Around 10 billion years ago, the two collided. The smaller galaxy was swallowed, its structure destroyed, but its stars survived, flung into elongated orbits that passed through the Milky Way's center and back out again like comets, forever looping through the heart of their devourer. For eons, those ghosts were invisible to us. To the human eye, the stars of Gaia Enceladus look no different from any other point of light. They hide in plain sight, mingled among billions of neighbors. Their secret was not in their color or brightness, but in their motion. Then came Gaia, the European Space Agency's precision mapping mission, launched in 2013. Its purpose was simple yet audacious: to chart the positions, motions, and brightness of over 1 billion stars in the Milky Way with exquisite accuracy. By measuring how each star drifts across the sky, Gaia effectively gave astronomers a three-dimensional movie of our galaxy, time compressed into data, every pixel a moving life. When those motions were plotted, a strange pattern appeared. Among the sea of rotating stars, a distinct group was moving differently, almost at odds with the main flow. Their orbits were stretched and eccentric, plunging through the galactic center, rather than circling neatly around it. They also carried a unique chemical fingerprint, fewer heavy elements, older composition, signs of birth in a smaller, more primitive galaxy. Gaia had uncovered a buried history, the debris of a world that once circled on its own, now dissolved into the Milky Way's body. To visualize it, imagine standing beneath a dome of stars and suddenly being able to see not only where each one is, but where it's going. In your mind's eye, thin, glowing threads begin to appear, connecting stars that share the same path. Those threads arc across the heavens, looping and intertwining like silk ribbons caught in a slow wind. Some form vast rings wrapping the entire sky. Others cut diagonally through constellations, ghostly traces of streams that once belonged to independent galaxies. It is as though the Milky Way wears a veil, woven from the memories of what it has consumed. One of the most haunting of these is the Sagittarius stream, the ongoing remains of another small galaxy currently being devoured. Its stars trace a full circle around the sky, passing through Sagittarius, Scorpius, and the northern constellations. Astronomers have mapped its curves so precisely that we can see it looping behind the galactic disk like a trail of spilled light marking the path of the doomed. Every few 100 million years, the Milky Way tears another piece from its companion, stretching it thinner until it becomes a filament of stars barely held together. The Gaia Enceladus event, though much older, left a similar mark. Its stars form an invisible skeleton that shapes the halo around our galaxy. The thick disk and extra layer of older stars that lies between the thin disk and the halo may be one of its lasting consequences, created as the merger stirred and heated the Milky Way's early structure. Some of the most ancient globular clusters, those dense spheres of hundreds of thousands of stars, also bear the chemical and kinematic fingerprints of Gaia Enceladus. They are relics of that lost world, still orbiting together after 10 billion years. To think that the galaxy's serenity is built on such violence is humbling. Every graceful spiral arm owes part of its existence to collision and absorption. Galaxies grow not by gentle expansion, but by inheritance, each new generation built from the remains of the ones that came before. The Milky Way is an amalgam, a survivor that has worn many names and many faces, and yet there is beauty in this recycling of worlds. The stars of Gaia Enceladus, once strangers, now belong to a greater whole. They drift among native-born stars indistinguishable to the eye, but forever marked in their motion. Their orbits are their epitaphs inscribed in the invisible coordinates of space and time. Even now, Gaia continues to refine this portrait. Each new data release adds millions of measured motions, turning the galaxy's chaos into a coherent dance. Astronomers can rewind the orbits in their models, watching the Milky Way spin backward in time until the streams converge, the ghosts reunite, and the lost galaxies briefly take shape again before merging into the blur of memory. Imagine watching that film in reverse, the ribbons contracting, the scattered stars gathering back into distinct shapes, small galaxies returning to their original forms. You'd see the Milky Way's past unfold like smoke reassembling into flame, and at the end of it, you'd witness a moment of creation not from nothing, but from joining a symphony born from collision harmony emerging from dissonance. When you look up tonight and trace the Milky Way's pale band, remember that you are seeing not a single entity but a congregation of worlds, each with its own vanished sky, its own lost constellations, its own dreams of permanence. Their ghosts still circle overhead, wrapped around the galaxy like strands of a forgotten melody. And their light even now travels through the dark to find us carrying a message older than the Earth, that in the universe nothing is truly gone. Everything endures, transformed, recombined, remembered in motion. Remembered. Every star carries a memory of its birth, and that memory is written not in words but in light. When astronomers speak of a star's chemical fingerprint, they mean the precise blend of elements, locked within its atmosphere, its personal pattern of metals, gases and traces of cosmic history. To study that pattern is to perform a kind of time travel. Each atom tells a story about when and where the star was born, what generations of suns lived and died before it, and how the universe itself evolved. It begins with the spectrum, the rainbow a star leaves when its light is split apart. To the naked eye, a star's glow seems pure and steady. But through a spectrograph, it becomes a landscape of valleys and peaks, dark lines slicing through colour. Each line marks a wavelength where light has been absorbed by a specific element: hydrogen, helium, calcium, iron, carbon, oxygen. These absorption lines are like letters in a hidden alphabet. When scientists compare them, they can read a star's composition as clearly as an archaeologist reads inscriptions on stone. In the early 19th century, astronomers began noticing that no two stellar spectra were identical. The sun's light, for instance, carries deep black lines known as Fraunhofer lines, each one corresponding to an element in its outer layers. Later discoveries revealed the significance. These lines were not just surface features, but signatures of cosmic lineage. Stars rich in heavy elements, the so-called metals in astronomical terms, are descendants of earlier generations that lived and died, seeding the galaxy with iron, carbon and oxygen through supernova. Stars poor in metals are ancient, forged when the universe was still young and almost pure hydrogen and helium. So when we look at a star, we aren't just seeing where it is, we're seeing when it is. Its chemistry acts like a time stamp. A star with almost no iron was likely born soon after the Big Bang, before the cosmos had many ways to make heavy elements. A star rich in metals was born much later in a galaxy already seasoned by billions of years of stellar death and rebirth. By mapping these chemical clues across the Milky Way, astronomers reconstruct not just the present galaxy, but its entire evolutionary tree, every merger, every burst of star formation, every echo of a supernova. It's a cosmic version of genealogy. We humans trace our ancestry through DNA, tiny spirals of code carried in our cells. The Milky Way does the same, but its DNA is atomic, the ratios of magnesium to iron, of carbon to nitrogen, of barium to europium. These are the markers that tell where a star belongs, whether it was born in the quiet arms of the Milky Way or imported from some devoured dwarf galaxy. By comparing these ratios, scientists can sort stars into families. Some belong to ancient clans that predate the spiral structure itself. Others are newcomers, their chemistry echoing alien origins. Each observation becomes an act of translation. The spectrograph, a long, gleaming instrument that disperses starlight into colour, is our translator between physics and poetry. When its detectors record faint spectra from distant stars, they're not just gathering data. They're listening to voices billions of years old. Every dark line in that spectrum is a word spoken by the universe in the only language it has ever used, light interacting with matter. To picture this, imagine a team of archaeologists dusting off layers of an ancient mural, revealing fragments of colour and shape. Piece by piece they reconstruct a forgotten civilization. Now replace pigment with photons. Astronomers do the same in the dark, restoring the history of the galaxy, not from ruins, but from spectra patterns of light that have travelled for thousands or millions of years to reach us. Through these spectral hieroglyphs we see stars as they were, and through them as we once were too. Some of the most metal-poor stars like SMSS, JSO 343-136-67L839.3 contain almost no iron at all, less than 1/10,000,000th of the Sun's abundance. They are thought to be second-generation stars born from gas enriched by a single massive supernova, perhaps one of the first explosions after the universe began. In their faint glow lies the residue of a time when only the simplest elements existed. Observing them is like finding a shard of pottery from the dawn of civilization still intact after 13 billion years, and at the other extreme there are stars so chemically complex that they reveal the fingerprints of multiple generations of life and death. They are cosmic cities built atop countless buried layers, each explosion leaving behind new ingredients. These later stars carry the richness of maturity carbon for life silicon, for rock iron, for blood and planets. When you study their spectra, you see the echoes of everything that came before the ashes of supernova, the whispers of neutron-star collisions, the alchemy of time. Through this lens, chemistry becomes more than science. It becomes biography. Every element in a star's atmosphere is a word in a universal language of memory. When astronomers say a star is metal-poor or alpha-enhanced, they are really describing its childhood, the neighbourhood it was born in, the company it kept, the violence that shaped it. Some were raised in crowded starbursts, others in quiet outskirts. All carry traces of their ancestors just as we do. It's humbling to realise that the same elements written in those spectra are written in us. The calcium in your bones, the iron in your blood, the oxygen in your breath, all of it once traced similar spectral lines in ancient stars. To study starlight then is not just to look outward, but inward, to recognise that the code of the cosmos and the code of our bodies are pages of the same book. So when astronomers point their instruments at the night sky, they are not only measuring, they are listening to light that has travelled across centuries of darkness to whisper, "This is where I came from. This is what I am made of." And with each line decoded, each element identified, the past grows clearer. The Milky Way's story unfolding not in myth or memory, but in the language of atoms and time. Across the night sky, invisible rivers flow, vast silent currents of stars winding through the dark. They cannot be seen with the naked eye. To us the heavens look still. But beneath that stillness, the Milky Way moves like a great ocean. And through that ocean, these stellar streams trace their patient paths, long ribbons of light drawn out by gravity and time. Each stream is a memory of collision. Long ago, a smaller galaxy or star cluster wandered too close to the Milky Way's gravitational pull. Caught in its tide, the intruder began to unravel. Its outer stars were the first to go stretched into faint trails that curved around the galaxy like strands of silk. Over millions of years, the smaller body was stripped down completely, its stars dispersed, its identity erased. But the pattern of its destruction remained preserved as a flowing arc of light that circles the sky. Astronomers have found dozens of these ghostly streams. Some loop above the galactic plane, some cut across it at strange angles, and some, like the Great Sagittarius Stream, wrap around the entire Milky Way in an immense broken ring. They are the handwriting of cosmic time scrawled across the darkness, in arcs too vast for any telescope to see all at once. When the European Space Agency's Gaia mission began mapping stellar motion, these hidden rivers came into focus. Suddenly, astronomers could see not just where stars were, but where they were going. By tracking millions of stellar trajectories, the data revealed faint structures woven through the galaxy like spider silk. In those patterns lay history, each stream corresponding to a specific merger, a specific act of creation through destruction. To picture one is to imagine standing atop a mountain after heavy rain, looking down on a landscape carved by water. Rivers snake through valleys, branching and rejoining, each path shaped by what has come before gravity erosion, the slow weight of time. The Milky Way is no different. Its stellar streams are its rivers, etched not by water, but by gravity. They tell us where smaller galaxies once flowed into ours, and how their courses changed the shape of the whole. The galaxy, like Earth, remembers its weather. The GD1 stream, for instance, stretches across half the northern sky, the remains of a long-vanished globular cluster. Its stars travel together, still thin and precise, as if they remember the boundaries of a home that no longer exists. The orphan stream drifts far above the galactic plane, a lonely remnant of a captured dwarf galaxy. And the Helmy stream, named after astronomer Amina Helmy, who discovered it, carries stars over 11 billion years old, some of the earliest immigrants to the Milky Way still orbiting like fossils in motion. These stellar streams do more than tell stories. They reshape our understanding of the galaxy's architecture. By tracing their arcs, astronomers can measure the unseen gravity of the Milky Way's dark matter halo. Each stream bends and twists in response to invisible mass, allowing us to map what cannot be seen. The rivers of starlight become instruments, delicate gauges, revealing the hidden structure of the cosmic landscape. But beyond their scientific importance, there is something deeply poetic about them. They are the afterimage of belonging, the signature of what happens when one world becomes part of another. The galaxies that made these streams no longer exist in any recognizable form, yet their stars continue to move together, holding formation across billions of years. Even in dissolution, there is coherence. Even in loss, there is pattern. Think of how rivers on Earth carry the memory of mountains long worn away. They continue to flow through valleys that no longer remember their peaks, cutting paths through time itself. The Milky Way's stellar streams do the same. They are erosion made visible in lighter cosmic hydrology. The difference is that these rivers flow not downward, but endlessly around, encircling the galactic core in slow luminous loops. If we could see them from outside the galaxy, the view would be breathtaking, hundreds of gossamer filaments twining around the spiral disk, shimmering like the veins of a living organism. Each one would be a path carved by gravity's persistence, a frozen current still moving after 10 billion years. Here on Earth we know rivers by their sounds, the murmur over stones, the whisper of current in reeds. The galaxy's rivers are silent, yet they speak through light. When astronomers point their instruments skyward, they are listening to that silence, tracing the echoes of ancient tides. And somewhere within those arcs, the sun too makes its journey, carried along by the slow, shared motion of the Milky Way's current. We are part of these invisible rivers, though we cannot feel them. We drift through them, unaware passengers in a vast hydrology of stars. In that sense, every night sky is a map of memory. Each faint star above you may once have belonged to another galaxy, another home. Together they form a web of connection, a reminder that nothing in the universe ever truly disappears. It merely changes shape, continuing to flow. The streams keep circling, tracing what was lost. The galaxy keeps turning, reshaping itself with each slow revolution. And in that endless motion, the Milky Way remembers its history, written not in stone, but in rivers of light moving forever through the dark. From afar, you might imagine the Milky Way as a flawless spiral, flat, balanced and calm. But our galaxy is not perfectly even. Its great disk of stars bends and flexes, one edge curling slightly upward, the other dipping down as though the whole structure were caught in a slow cosmic wave. This distortion is called the galactic warp, and it's one of the most graceful imperfections in the universe. You can picture it like a spinning vinyl record left too long in the sun, still playing its song, still turning, but warped just enough that the needle rises and falls in rhythm with the groove. The Milky Way behaves in much the same way, its stars and gas dancing to a pattern of invisible forces that lift and tilt the edges of the disk. To live inside it as we do is to ride that slow motion without ever feeling it gliding through a galaxy that breathes like a vast luminous ribbon. The warp was invisible to early astronomers. Through optical telescopes, the Milky Way's dust and distance hide its shape from within. Only when radio astronomers began mapping the faint 21-centimetre emission of neutral hydrogen, a signal that passes through the dust, did the true form emerge. The hydrogen gas stretching far beyond the visible starlight revealed a sheet not flat but bent, curling up in one direction and down in the other, like the edge of a softly turning page. At first, no one was sure what caused it. Was the Milky Way itself twisting from within, or was something outside tugging at its edges? Over time, evidence pointed to both a combination of gentle nudges from our satellite galaxies, particularly the large and small Magellanic Clouds, and the uneven pull of dark matter, the invisible mass that surrounds us like a halo. The Magellanic Clouds, bright patches in the southern sky, are small galaxies orbiting the Milky Way like distant companions. As they move, they drag long tails of gas the Magellanic Stream, and their gravity tugs subtly at the Milky Way's outer disk. Each pass of these satellites sends a ripple through the galaxy, like a pebble dropped in still water. The waves propagate across hundreds of thousands of light years, slow and stately, taking millions of years to crest and fade. Our galactic plane, rather than being rigid, responds like fabric flexing to every distant touch. Then, there is the unseen hand of dark matter. The Milky Way floats inside a vast halo of this mysterious substance, invisible but massive enough to bind the galaxy together. If that halo is slightly uneven, denser on one side, lopsided or stirred by past collisions, it can distort the gravitational field that holds the stars. The result is a tilt, a twist, a graceful asymmetry that refuses to settle. Recent observations from the Gaia mission have made it clear that the warp is not static. It precesses, slowly rotating over time like the wobble of a spinning top. Every few 100 million years, the pattern shifts the wave passing through the disk as stars rise and fall around the galactic midplane. This motion means that the Milky Way is still responding to forces still being shaped, still alive. If you could see it from outside from the view of some faraway intergalactic traveller, the Milky Way would not be a perfect pinwheel. It would look like a shimmering ribbon undulating through the dark, one side lifting gently toward the Magellanic Clouds, the other dipping toward the void. Its spiral arms would seem to breathe, expanding and contracting in rhythm with the slow pulse of time, and within that grand movement our solar system rides along. As the galaxy flexes, we sway with it rising and falling through the mid-plane every few dozen million years, tracing a wave pattern of our own. Some scientists have speculated that this oscillation might subtly influence Earth's climate, or even its biosphere, though the evidence remains uncertain. Still, it's humbling to think that the long tides of the galaxy might ripple faintly through the history of life. The warp reminds us that nothing in the cosmos is perfectly stable. Even structures that seem eternal are in truth elastic, shaped by contact tension and time. Like a spinning record, the galaxy's music is written in vibration. The warp is its quiet bass line, deep and slow, a rhythm that only the patient can hear. And as we listen, as we map the hydrogen and trace the tilt, we begin to understand the lesson hidden in that gentle curve, that beauty lies not in symmetry but in response. The Milky Way's disk bends because it feels. It remembers every passing influence, every encounter, every hidden mass brushing by in the dark. Its warp is not a flaw, it is a signature, a proof that even on galactic scales, perfection is not stillness but movement. If you've ever stood beneath a sky unspoiled by city lights out in the desert, or on a high mountain or somewhere deep in the countryside, you may have felt that ancient shiver of awe. The Milky Way arches above you in a river of silver, a vast mist of stars spilling from horizon to horizon. It feels infinite. You might even think you're seeing everything there is to see. But you aren't, not even close. What you can see with your eyes, every glittering point, every wisp of starlight amounts to only 0.003% of the Milky Way's true population. Out of perhaps 400 billion stars, you're glimpsing only a few thousand. The rest are hidden, veiled behind dust, drowned in distance, or too faint for your retinas to register. You are standing beneath a cosmic ocean, but what reaches you are just the brightest ripples on its surface. The thought is both humbling and liberating. Even when you feel surrounded by light, you're in the presence of the unseen. The night sky is not a ceiling studded with jewels. It's a thin, transparent skin stretched over vastness. Every visible star is a nearby neighbour, a local ember. The Milky Way extends far beyond a colossal spiral whose arms wrap hundreds of thousands of light years through the dark. What your eyes mistake for completeness is only a spark on the edge of a lantern. Imagine for a moment that all human vision could be switched off, every light, every candle, every sense of brightness gone. Now imagine that you could still perceive radiation in all wavelengths: infrared, radio, X-ray, ultraviolet. The sky would bloom open. The darkness would dissolve into layers upon layers of hidden structures. You'd see the glow of cold hydrogen gas tracing the galaxy's skeleton, vast ribbons of radio light flowing between the stars. You'd see nebulae blazing in infrared, where newborn suns still sleep inside cocoons of dust. You'd see X-rays pouring from supernova remnants and the edges of black holes in visible violence painted in colourless light. Then look again with the eyes we actually have. Those two tiny windows evolved to catch a narrow slice of the electromagnetic spectrum. The universe dims back to near nothing. What was once a symphony becomes a whisper. We live surrounded by a flood of invisible energy, yet our perception filters it down to a candle flame. And somehow in that faint glow, we find beauty enough to fill a lifetime. When astronomers began to explore beyond visible light, they realized how blind we had been. Radio telescopes revealed colossal structures stretching far beyond the galactic plane. Infrared instruments like Spitzer and JWST unveiled regions where stars are born glowing softly behind curtains of dust. X-ray observatories like Chandra exposed the violent underworld of black holes and exploding suns. Each wavelength adds a layer of reality, and together they form a portrait so immense and complex that the visible Milky Way, the one that feels vast to us, is little more than its shadow. And yet even that shadow is enough to stir the soul. That thin streak of starlight across the sky, the one ancient people called the River of Heaven, is a doorway to everything hidden. To stand beneath it is to stand on the edge of perception itself. You are the witness of a great illusion that also happens to be true. There is a kind of kindness in the darkness. If our eyes could see all that exists, the gamma ray flares, the ultraviolet storms, the seething heat between the stars, we might never find rest. The limited human gaze confined to visible light grants us mercy. It allows beauty to take shape within boundaries. The Milky Way we see is the dream version, softened and luminous, edited for sleep. So when you find yourself beneath a sky, untouched by noise or light, try this small thought experiment. Take a slow breath and imagine the invisible. Imagine the stars beyond those you can see, layer upon layer, until the sky fills entirely with radiance, every atom glowing. Picture the hidden streams of dust and gas, the currents of magnetism, the unseen particles passing through your body every second. You're not standing under a sky, you're floating inside it. You are part of the galaxy's light, part of its blindness too. And when you open your eyes again, the few thousand stars visible to you will look different. They will no longer feel small, they will feel miraculous, because they are the rare ones, the ones that manage to cross the immense distance, the dust, the veils of time, and still reach you. Out of hundreds of billions of lights, these are the ones that found their way through. That realization, quiet and staggering, is what it means to look at the night sky with awareness, to know that what you see is only the beginning, and that the rest, the greater part, still waits beyond the dark. If you could rise far above the Milky Way and look down, not with human eyes, but with the patience of time itself, you'd see that our galaxy isn't made of fixed, rigid arms. Those shining spirals aren't solid structures of stars locked in place. They are patterns, waves of density flowing through the galactic disk like ripples in a slow, luminous sea. The stars themselves drift in and out of these arms just as cars move through rush hour traffic. The illusion of permanence comes from the rhythm. Where stars, gas and dust bunch together, the galaxy glows more brightly, tracing the spiral pattern we recognize. But each of those glowing regions is only temporary, a momentary jam in the great traffic of stars. Over millions of years, individual stars move on, the pattern stays, and the dance continues. Astronomers call these regions spiral density waves. They form because not every star orbits the galactic center at the same speed. Stars closer to the core move faster, those farther out move slower, and between them lies a delicate balance, a gradient of motion. As these different speeds interact, areas of higher density emerge, compressing gas clouds as they pass. Those clouds collapse, ignite, and form new stars. The spiral arms are not lines of matter, but lines of creation moving through the disk like gentle shock fronts of light. Imagine for a moment that you're floating high above a modern city at night. Beneath you, highways curve in looping arcs, headlights streaming in ribbons of white and red. From this distance, the cars look like a single glowing pattern flowing smoothly. But if you look closer, you see something else. The cars themselves inch forward, stop and move again. The traffic jam isn't a wall, it's a wave. Each driver eventually moves through it, yet the congestion remains drifting down the road like a slow-moving pulse. The Milky Way behaves much the same way. Each spiral arm is a luminous traffic jam where material crowds together under the influence of gravity and orbital motion. Stars form in these congested lanes, live their bright, brief lives, and then drift onward into quieter galactic neighborhoods. The arm persists not because the same stars stay there, but because the wave keeps moving through new material. The Sun too is part of this long commute. It orbits the galactic center once every 225 million years, crossing spiral arms like a commuter passing through different districts of a vast cosmic city. Sometimes it drifts through calm stretches of the disk. Other times it enters the glowing congestion of an arm surrounded by denser clouds and young hot stars. Our solar system has likely passed through several such regions since it formed, each one shaping the environment around it, in subtle ways, perhaps even influencing life on Earth through changes in cosmic radiation or comet influxes. To imagine the scale of this motion is to surrender any sense of stillness. Even as you read this, our Sun is travelling at more than 230 kilometers per second, fast enough to circle the entire Milky Way in 250 million years, and yet everything around you feels perfectly still. That's the strange quiet of cosmic motion speed, without sound acceleration, without sensation. These waves of density explain not only the spiral arms, but also their gentle glow. When the wave compresses, a cloud of gas gravity takes over. The gas collapses into clusters of young massive stars whose ultraviolet light illuminates the surrounding dust. Seen from afar, those glowing curls of blue and silver trace the shape of the arms. Then as the young stars die and the wave passes, the brightness fades, leaving behind older, cooler stars that drift in the background until the next wave arrives. So the spiral arms are not things but moment-standing patterns of motion sustained by billions of orbits. The Milky Way doesn't rotate like a wheel. It circulates like weather, its arms as ephemeral as cloud formations seen from orbit. And yet, in that transience there is order. The arms form, dissolve and reform, maintaining the galaxy's familiar shape across billions of years. It is a choreography of impermanence, a structure that exists only through constant change. When you look up at the band of the Milky Way, try to picture it not as a frozen image, but as an unfolding dance. Every pinprick of light you see is moving forward, backward, inward, outward, yet somehow all together they form a steady pattern, just as the headlights of a city's freeways form streams of brilliance when seen from space. The galaxy's beauty is a trick of perspective movement so vast and slow it feels like stillness. It's easy to forget that we're part of this motion, one small speck flowing in the current, but in a way that makes it more profound. We live inside the traffic jam, yet we're also the observers of it, conscious particles aware of the pattern we inhabit. The same laws that sculpt spiral arms also govern the orbit of Earth, the pull of the Moon, and the beating of our own hearts. The Milky Way's spiral arms are its pulse, its living rhythm, a slow heartbeat of gravity and light. From our small planet, we see only the shimmer of that pattern, unaware that beneath its calm surface an entire galaxy is flowing. When you gaze at the Milky Way, you see its stars, its gas clouds, and the soft haze of dust drifting between them. You see the visible, the part that glows. But what holds all of it together, what gives the galaxy its shape, its spin, its endurance across billions of years, is something you cannot see at all. It does not shine, it does not absorb, it does not collide or reflect. And yet it outweighs everything visible many times over. Astronomers call it dark matter, the invisible scaffold on which the Milky Way hangs. The story of its discovery is one of quiet astonishment. In the 1930s, Swiss astronomer Fritz Zwicky studied the Coma Cluster, a vast congregation of galaxies bound by gravity. When he calculated how fast those galaxies were moving, he found something impossible. They were going too fast to stay bound by the mass of the visible stars alone. By Newton's laws, they should have scattered into the void long ago. But they hadn't. Something unseen, some extra gravity was holding them together. Zwicky called it Dunkelmaterie, dark matter. Decades later, Vera Rubin, an American astronomer, made a similar discovery within our own galactic neighborhood. Measuring the rotation of spiral galaxies, she expected to find that stars farther from the center moved more slowly, just as planets in our solar system do, where outer orbits take longer to complete. But what she found defied reason. Stars at the edges were moving just as fast as those near the core. According to the laws of motion, the galaxies should have flown apart like fireworks. Instead, they held. The only explanation was that an enormous invisible mass surrounded them, something extending far beyond the luminous disk anchoring every orbit in silence. Today, every model of the Milky Way begins with that dark foundation. Around our glowing spiral lies a halo of unseen matter, a spherical shroud stretching hundreds of thousands of light years in every direction. It outweighs all the stars, gas and dust combined perhaps 5 or 6 times over. It is the galaxy's skeleton, the quiet architecture that keeps the structure intact. Without it, the spiral would unravel. The outer stars would fly away like sparks from a wheel. The Milky Way exists because the unseen allows the seen to persist, and yet we still don't know what it is. For nearly a century, physicists have searched for the particles that make up dark matter. WIMPs, axions, sterile neutrinos, even exotic new forms of physics. But so far, every detector has found only silence. The mystery remains an invisible truth confirmed by everything it touches, but never by its own voice. We know it's there because without it, nothing we observe makes sense. There's something strangely human about that kind of knowledge, believing in what you cannot see, guided by evidence that appears only through consequence. The orbits of stars are our proof. Their faithful circles are the handwriting of an unseen gravity. Dark matter is in a way the cosmos asking us to trust the invisible. Astronomers often describe it poetically as the scaffold of the universe. In the earliest moments after the Big Bang, it was dark matter that began to gather, forming a web of gravitational threads. Ordinary matter gas dust light later fell into those filaments, condensing into galaxies. The Milky Way, like all other galaxies, grew along one strand of that vast cosmic web. Everything we see is draped across a structure that does not shine. To imagine it is to imagine the universe as lace an immense network of invisible filaments, each strand tugging gently at the next. The stars and galaxies are only beads along those threads, glowing markers of a deeper pattern. The Milky Way's spiral arms, its halo, its quiet rotation, all of it is suspended within that unseen architecture. And perhaps that's why the idea of dark matter feels so strangely spiritual. It's not mystical, but it does require a kind of humility, the willingness to admit that most of reality is beyond our perception. The visible universe, magnificent as it is, may be only the surface of something deeper. We live inside a cathedral of gravity, its pillars invisible, its arches made of silence. Every rotation of the Milky Way, every orbit of the sun, every steady motion of the Earth is a kind of prayer to that hidden mass, a motion of trust. The stars move faithfully in circles they cannot explain, bound by a force they will never see, and we, bound to those same laws, can only measure info and wonder. When you look at the night sky, you're not just seeing stars, you're seeing the part the darkness allows. The real Milky Way is larger, heavier, more mysterious than its luminous self. We are surrounded by gravity's shadow, an invisible hand shaping everything we know. Dark matter does not glow, but without it nothing would hold together, not galaxies, not clusters, not us. It is the unseen order beneath all motion, the silence beneath the song. And maybe that's the truest beauty of the cosmos, that what you cannot see is what keeps you here. At the very center of the Milky Way, 40,000 light-years from where you are reading this, lies a point of almost perfect darkness. It has no surface, no light, no boundary that you could touch, and yet it holds sway over the motion of an entire galaxy. This is Sagittarius A, the Milky Way's supermassive black hole, a gravitational heart millions of times heavier than the Sun and smaller than the orbit of Mercury. We cannot see it directly. What we see are the stars that orbit it, moving in tight, frantic loops around something that isn't there. For decades, astronomers in Chile and Hawaii have aimed infrared telescopes toward the constellation Sagittarius, peering through curtains of dust that obscure the galactic core. There, in the crowded central light, they watched the same cluster of stars year after year, measuring their motion like careful pulse takers at the bedside of a sleeping giant. One of those stars, called S2, became the most famous. Every 16 years, it completes an elongated ellipse around the invisible center. At its closest approach, it rushes past Sagittarius A at more than 5,000 kilometers per second, faster than any other known star. Then it swings back outward again, tracing a perfect curve that can only be drawn by a massive compact object. By following S2 and its neighbours, scientists confirmed beyond doubt that the Milky Way's heart contains about 4 million solar masses, all packed into a space no larger than our solar system. It is an astonishing combination of violence and stillness. Around Sagittarius, a gravity becomes music at the edge of hearing. Stars whip gas whirls, time itself bends. But at the centre there is silence, no roar, no light, only the steady gravity of a collapsed star beyond reason. A black hole does not devour in fury, it waits. Matter drawn too close spirals inward, heating to millions of degrees, releasing X-rays and radio waves before disappearing across the event horizon. The light flickers, fades and vanishes, leaving only the curved geometry of space. When astronomers combined the power of telescopes around the world to form the Event Horizon Telescope, they captured the first image of Sagittarius A in 2022, a faint blurry ring surrounding a shadow. That orange halo was not the black hole itself, but the last light escaping from the maelstrom of gas about to fall in. It was a photograph of gravity's boundary, the point where time folds back on itself. To see it was to glimpse the Milky Way's heartbeat for the first time, and yet despite the violence implied by its name, Sagittarius A is remarkably quiet. Compared to the raging quasars at the cores of distant galaxies, our black hole feeds sparingly. It is more a sleeping heart than a hungry monster, pulsing gently rather than roaring. Occasionally flares of X-rays reveal brief meals, perhaps a fragment of gas, or a wayward asteroid torn apart, but then the glow subsides and the darkness closes again. For most of cosmic history, it has simply waited, shaping the orbits of stars and clouds, anchoring the galactic swirl. If you could stand somewhere near it, though you never truly could, the view would be both terrifying and sublime. The sky would bend around you, the stars smeared into arcs of light, their colours twisted by gravity. Behind you, the rest of the Milky Way would stretch across the black hole's horizon like a reflection in rippled water. You would not fall, you would drift, crossing an invisible line where space itself moves faster than light, carrying you inward to a region where inside and future mean the same thing. From our safe distance, we orbit within the influence of that darkness, without ever feeling it. The sun, Earth, and every star you can see circle quietly around this hidden anchor. It is the reason the galaxy coheres, the reason our cosmic city does not drift apart. And perhaps there is a strange comfort in that all of us, all life, all light, turn around something we can never see. In the grand stillness of the night sky, Sagittarius A is both absence and presence, silence and structure. It is the pause between heartbeats, the dark centre around which the luminous arms revolve. Every star's path, every spiral of gas, every orbit of our own sun is a part of its gravity's song, and though it will never wake, it continues to shape the rhythm of the galaxy, proof that sometimes the deepest power in the universe lies not in what burns, but in what waits. At the heart of the Milky Way, just outside the quiet gravity of Sagittarius A, the galaxy thickens and swells not into a sphere, but into something stranger, a peanut-shaped bulge. It's an elegant imperfection, a swollen hourglass of stars rising above and below the galactic plane, glowing faintly through the dust that heeds it from our eyes. If we could step outside the galaxy and look down upon it from afar, we would see that our beautiful spiral isn't evenly flat at all. Its core curves upward like the lobes of a seed, cradling the spinning bar of stars that forms its inner spine. The Milky Way's central bar is the key to this shape. Imagine a bridge of starlight cutting through the galactic centre, about 25,000 light-years long, rotating slowly like a cosmic turnstile. Its billions of stars move in elongated orbits that stretch along the bar's length, drawing gas inward and sending new material outward, a gravitational circulation that keeps the inner galaxy alive. Over time, this rotating bar has gently reshaped the central bulge, lifting some of its stars above the disk and pressing others below, until the whole structure resembles a glowing peanut seen edge-on. The physics behind it is subtle, almost organic. In a flat disk of stars, small imbalances can grow over billions of years. A slight asymmetry, a ripple of density, or a pattern of orbits can elongate into a bar. Once formed, that bar exerts a new rhythm on the surrounding stars, tugging some onto paths that lift them above the plane. These orbits trace X-shaped trajectories when viewed from the side, two streams rising, two sinking, crossing at the center. The combined light of billions of such stars produces the hourglass glow that astronomers see in infrared images from missions like Kobe Spitzer and WISE. If you could watch the Milky Way's evolution in a time-lapse spanning billions of years, you would see something like this first. The young galaxy spins its disk, forming clean spirals around the dark heart. Then gradually the core begins to twist. The orbits of its stars lengthen, aligning into a central bar that rotates like the handle of a great wheel. Gas clouds drawn inward by the bar's gravity compress into new generations of stars that light up the inner region. The bar thickens, and under the slow push and pull of resonances, places where orbital speeds match the bar's rotation, it buckles upward and downward. The midplane inflates. The once round bulge blossoms into two lobes curving outward like the shell of a peanut. Seen from above, it remains a barred spiral, two luminous arms unfurling from the bar's ends winding outward into the disk. Seen from the side, it looks alive, breathing through the ages, the bar turning like a steady heartbeat, while the bulge rises and falls in a quiet pulse. Astronomers have traced this structure using millions of red giant stars mapped by the Gaia and Vista surveys. Their positions outline a clear X, each limb a stream of stars following the rhythm of the bar. It's a revelation the Milky Way's inner light is not a simple sphere, but a dynamic sculpture carved by motion itself. The effect is not unique to us. Many barred spirals in the universe show the same feature, this peanut-shaped bulge, this subtle swelling of the heart. It is how galaxies age, gracefully trading symmetry for character. The bar acts as both architect and conveyor belt, funneling gas toward the center to feed star formation near Sagittarius A, while slowly redistributing angular momentum through the disk. Without it, the Milky Way would be quieter, rounder, and perhaps less alive. If we could somehow fly above our galaxy and watch it turn, we'd see the bar glowing amber at the core, its ends touching the spiral arms like a bridge between calm and motion. Around it, the X-shaped bulge would gleam faintly in infrared, two lobes of starlight arching up and down, sculpted by gravity's artistry. Each star within would trace a slow orbit like a bead sliding on a curved wire, repeating its loop for eons, keeping the central structure intact. There is something poetic in that persistence. The Milky Way's center is not a place of chaos, but of structured turbulence, a balance between order and distortion. The bar pulls, the bulge bends, and together they form a stable rhythm, a dynamic piece that has lasted for billions of years. So when you imagine the Milky Way tonight, don't see it as a perfect flat swirl. Picture it instead as a living form, a spiral with a spine, a heart that curves and flexes, a galaxy shaped by motion into grace. The bar turns, the peanut glows, the stars flow like breath through the lungs of light. And through that slow eternal dance, the Milky Way keeps its form, not because it is rigid, but because it knows how to bend. In the spiral arms of the Milky Way, where gravity and time weave their most delicate patterns, lie the cradles of fire, vast nurseries of gas and dust where new stars are born. From afar, these regions look like faint veils or glowing wounds in the sky. Through telescopes, they reveal themselves as clouds of unimaginable beauty, pink, blue, and violet, illuminated from within by the very suns they have created. These are the giant molecular clouds, the wombs of the galaxy. Each one spans hundreds of light years and contains enough material to make millions of stars. They are made mostly of hydrogen, the same simple element that filled the early universe, but laced with traces of carbon, oxygen, and silicate dust, the inheritance of older generations of stars that lived, died, and returned their ashes to space. Within their cold interiors, temperatures fall to a few tens of degrees above absolute zero, and the darkness is nearly complete. Yet within that silence, creation begins. It starts with collapse. Somewhere inside the cloud, gravity gains a tiny advantage over pressure. A region slightly denser than its surroundings begins to pull inward, gathering material like a whirlpool in slow motion. Over hundreds of thousands of years, the gas condenses, heating as it falls until a glowing knot forms at the center, a protostar hidden within a cocoon of dust. Around it, a spinning disk begins to flatten where planets may one day form. Then one by one, the newborn stars ignite. Their cores reach millions of degrees, hydrogen fuses into helium, and light floods the darkness. The first ultraviolet rays burn through the surrounding gas, carving out cavities and glowing edges. The nebula, once invisible, bursts into radiance. It is as if the cloud itself has begun to breathe, exhaling light. Astronomers can see these stages across the sky: the Orion Nebula, a glowing cavern only 300 light-years away where thousands of young stars are still forming; the Eagle Nebula, with its towering pillars of creation sculpted by stellar winds; and the Carina Nebula, where massive newborn suns blast their birth clouds apart with storms of radiation. Each one is a portrait of creation and destruction entwined. In truth, every star in the night sky, everyone you've ever wished upon once formed in such a nursery, even the sun. About 4.6 billion years ago, it was just one ember among many in a collapsing molecular cloud. When it ignited, its radiation cleared the remnants of its cradle, scattering dust and gas into space. Some of that dust gathered into the planets, into Earth, into the matter that would one day breathe, speak, and look back in wonder. In that sense, every human being is made of nebular residue, the cooled glow of a long-vanished cloud. To watch a stellar nursery is to witness a cosmic parallel to human birth. The contraction of gas mirrors the gathering of cells, the ignition of fusion, the first heartbeat. The nebula glows not because it chooses to, but because life has begun inside it. Its ultraviolet light paints the surrounding clouds in blushes and blues, like the soft pulse of a womb illuminated from within. Through infrared telescopes such as James Webb, we can now pierce the dust and see what the human eye cannot the very moment of ignition. Behind the glowing curtains, countless infant suns spin in their disks, invisible in visible light, but blazing in heat. Their jets carve linear scars through the surrounding gas, announcing their arrival with beams of light years in length. The nebula seen in such detail resembles not chaos, but choreography, billions of tons of gas moving in harmony to the laws of physics, which here become the laws of birth. Yet even as the nursery shines, it is already dying. The young stars that illuminate it are also destroying it. Their ultraviolet light ionizes the surrounding hydrogen, heating it until it expands and disperses. The same radiation that paints the nebula in color also tears it apart. Creation and destruction, birth and departure are inseparable. The beauty of a nebula is always the beauty of a farewell. Still, the pattern continues. The scattered dust will drift for millions of years, eventually forming new clouds, new collapses, new stars. The galaxy renews itself through these endless cycles, each one both an ending and a beginning. So when you see an image of a nebula, the glowing pinks of Orion, the emerald wisps of Carina, the violet folds of the lagoon, remember that you are looking at the galaxy's maternity ward. Every shimmer is a birth cry, every shadow a cradle. The same processes that light those distant clouds once shaped the atoms in your own body. You are quite literally a descendant of a nebula, a child of dust and fusion, a spark born from the Milky Way's long labour. And somewhere out there, new suns are kindling, even now their ultraviolet hands already painting their first colours into the dark. Far beyond the Milky Way's bright spiral arms, past the last traces of gas and the faintest drifting stars, lies a realm of ancient light, the galactic halo. It surrounds the Milky Way like a faint invisible sphere reaching hundreds of thousands of light years in every direction. It is not smooth, not luminous, not young. It is a place of ghosts, old stars, old clusters, and old stories that have been circling since the dawn of the galaxy itself. Here the light is thin but steadfast. Scattered across the halo are more than 150 globular clusters, tight spherical gatherings of hundreds of thousands of stars bound together by gravity. Each cluster glows like a lantern in the dark, an island of order adrift in the galactic sea. They are among the oldest surviving structures in the universe, fossils of the Milky Way's youth. Some, like M92 in Hercules and NGC 6397 in Ara, are more than 13 billion years old, nearly as old as the cosmos itself. When the first galaxies were just assembling, these clusters were already burning quietly, their stars now faded to steady amber light. To look at a globular cluster through a telescope is to gaze back into prehistory. What appears at first as a soft glow resolves into countless points of light so densely packed that in their centres stars are only a fraction of a light year apart. If you could stand on a planet within such a cluster, though planets there would be rare and fragile, your night sky would never grow dark. Tens of thousands of suns would blaze in every direction, crowding the heavens in perpetual twilight. The halo's stars move differently from those in the disk. They do not share the galaxy's rotation. They wander on long, looping orbits that tilt and twist, some even moving backward relative to the spiral's spin. Many are immigrants, remnants of small galaxies consumed by the Milky Way long ago, their stellar population scattered into this faint sphere. In that sense, the halo is both a graveyard and a memory holding the remains of every merger, every lost companion that helped build the galaxy we now inhabit. For astronomers, it is a laboratory of cosmic patience. Time moves differently here, not because the laws of physics change, but because the stars themselves do not hurry. Most halo stars are metal poor, containing almost none of the heavy elements forged by later generations of supernovae. They burn slowly, conserving their fuel across tens of billions of years. To measure their light is to measure endurance itself. If the galactic disk is a city bright, restless, full of creation and destruction, the halo is the countryside that never sleeps but never rushes. It watches from afar while the spiral within spins and flickers its stars like elders sitting at the edge of a fire, remembering when the flames first began. The globular clusters are its storytellers. Their stars orbit a common center, like monks, circling a sacred flame, their light steady, unwavering. Some clusters have survived close encounters with the Milky Way's core tidal forces, stretching and heating them, yet they remain intact proof that even in a universe ruled by change, certain forms of beauty endure. In the halo, distance becomes abstraction. The space between clusters is so vast that light from one may travel millions of years before it brushes the outskirts of another. Yet all of them, scattered and silent, are connected by gravity's invisible web circling the same center, Sagittarius A, the heart they have known since birth. Modern surveys like Gaia and Hubble have begun mapping this ancient architecture in exquisite detail, tracing the faint streams of stars that arc between clusters, remnants of long-vanished systems. Each stream is a line in the galaxy's memory, the lingering handwriting of creation. And so the halo glows not brightly but profoundly. Its light is the color of survival, dim gold, patient silver, the hues of endurance. It is the Milky Way's elder skin weathered by time, holding within it all the forgotten beginnings that made the present possible. When you look up at the night sky and see the Milky Way's band stretching across the dark, remember that beyond that luminous river lies this ancient sea. Its stars were old before the sun existed. They have seen galaxies collide, arms twist, dust bloom into planets, and fade again. They will still be shining long after our own star has dimmed. The halo is the galaxy's memory, the wisdom of age written in light that refuses to go out. It watches unhurried while the younger stars dance below its glow, a whisper across eternity reminding the universe that endurance too is a form of brilliance. The Milky Way is no longer young. It has passed through its brilliant adolescence, the era when stars ignited in furious numbers, when nebulae blazed across its arms like bonfires, and supernovae lit the dark with furious light. Today, our galaxy stands in a quieter, steadier phase of its life, a middle-aged galaxy not yet fading, but no longer in its exuberant youth. Astronomers can measure this maturity in the simplest way possible, by counting how many new stars are being born. Billions of years ago, the Milky Way's star formation rate was 10 times higher than it is now. Clouds of hydrogen collapsed, constantly birthing suns by the millions. It was an age of expansion, of creation, of risk. The galaxy was growing, fast-fed by fresh gas from intergalactic space, and collisions with smaller companions. But over time, that raw fuel dwindled. The easy reservoirs of gas were used up, locked into stars, planets, and dust. The great molecular clouds now form more slowly and fewer of them collapse. In this sense, the Milky Way is like a vast city that has finished its most frantic century of building. Its foundations are laid, its neighborhoods settled, its tempo more measured. The skyscrapers, the bright clusters and starbursts still rise now and then, but most of the lights belong to older dwellings, stable and enduring. What once was a construction site has become a civilization. Astronomers call this phase galactic quiescence, but quiet does not mean lifeless. The Milky Way still gives birth to new stars, about 1 every year, compared to perhaps 10 per year in its youth, but it does so with calm precision. Its spiral arms continue to shimmer with nurseries of gas and dust, but the glow is softer, more deliberate. It has reached the cosmic equivalent of adulthood, productive, self-sustaining, aware of its limits. To imagine the contrast, think of cosmic adolescence, the wild epoch roughly 8 to 10 billion years ago, when the universe itself was bursting with energy. Galaxies collided frequently, their structures chaotic and their colors fierce with ultraviolet light from newborn stars. The cosmos was noisy, then bright, turbulent, impatient to grow. The Milky Way too was part of that frenzy, cannibalizing smaller galaxies, shaping its spiral arms through violence and hunger. But time even for galaxies brings perspective. As the universe expanded and cooled, the pace of star formation declined. Gravity and gas reached a balance. The Milky Way's bar and spiral arms stabilized into harmony. The collisions that once tore its structure apart grew rarer. The galaxy began to age gracefully, no longer a firestorm but a slow-turning lamp, conserving what remains of its fuel. In that long maturity there is a kind of cosmic reflection. The Milky Way now carries the weight of its history, the ghosts of devoured galaxies in its halo, the stars of ancient clusters orbiting patiently at its edge, the fresh-born suns of its arms shining for new worlds not yet aware of themselves. It has settled into a rhythm measured not by explosions, but by endurance. Still, its life is not over. Astronomers predict that the Milky Way has billions of years of steady light left before its next great transformation, the future collision with Andromeda now on a slow, inevitable approach. That meeting 5 billion years from now will merge two mature galaxies into one giant elliptical reigniting bursts of star formation, before finally fading into cosmic calm. Our galaxy in that sense is in its middle chapter, old enough to remember its youth, young enough to anticipate change. You might imagine the Milky Way at this moment as a person in their 40s or 50s standing on a quiet shore at dusk. The wild energy of youth has softened into wisdom. The horizon is still wide, but the rhythm has changed less, chasing more seeing. Every orbit, every star, every rotation of its bar is slower, steadier, more deliberate. There is beauty in this moderation. The spiral arms still shimmer with colour, but the spaces between them have deepened into serenity. The galaxy's heartbeat, its rate of star formation, has slowed but not stopped. It continues to hum softly in the dark, its light more introspective now, its pace more mindful. In its middle age, the Milky Way has become something more than a maker of stars. It has become a keeper of stories. Within its arms are suns that remember the beginning planets, where consciousness has bloomed, and dust that will someday become new life again. Its purpose is no longer just to build, but to preserve, to let experience accumulate, to allow meaning to settle like sediment at the bottom of a long river. Perhaps this is the quiet grace of galactic adulthood, not endless creation, but the balance between becoming and being. The Milky Way no longer rushes. It listens to its own motion, to the hum of the universe expanding around it, to the silence that waits beyond its stars. And as you stand beneath its glowing band, you're witnessing that same calm maturity, the slow breath of a galaxy that has learned at last how to rest while it still shines. Every star is a story, with a beginning, a middle, and an end, and for the most massive among them, that ending is anything but quiet. When a giant star dies, it doesn't simply fade away. It explodes, releasing in a few seconds more energy than our sun will produce in its entire lifetime. This is the supernova, the most transformative event in the Milky Way, the act of destruction that ensures creation can continue. To witness one would be to see light brighter than a galaxy flash in the sky. For weeks, a single dying star can outshine billions of others combined. Its outer layers are blown apart at thousands of kilometers per second, scattering gas dust and newly forged elements across space. Its core collapses into something unimaginably dense, a neutron star, or if massive enough, a black hole. And in that brief moment between implosion and silence, the universe performs one of its greatest miracles, alchemy. Inside these explosions, the elements of life are born. The heat and pressure reach levels so intense that atoms are forced together into new forms. Carbon and oxygen, made in the long fusion furnaces of the star's life, are joined by heavier elements, silicon, nickel, copper, and iron. For a few heartbeats of cosmic time, the star becomes a forge where nature makes what it cannot make anywhere else. Iron is the limit. Once a star's core begins to fuse iron, the process no longer yields energy, it consumes it. The fusion stops, gravity wins, and the collapse begins. In that moment of failure, the star fulfills its purpose. Its death releases everything it has ever created, enriching the surrounding space with the seeds of new worlds. From that debris, new stars will form, carrying traces of their ancestors. The iron in your blood, the calcium in your bones, the oxygen in every breath, all were forged in stars that lived and died long before the sun was born. When you press a hand to your chest, you are touching matter once held in the heart of a supernova. Even the gold in a ring or the silver of a spoon has a story that begins in stellar death. Gold, platinum, and other heavy elements come not from ordinary supernovae, but from even rarer events, the collisions of neutron stars where the wreckage of two dead suns compresses space itself and creates the universe's most precious materials in a flash of gamma rays and gravity. Each explosion sows the galaxy with possibility. The shockwaves from dying stars ripple outward, compressing nearby gas clouds and triggering new collapses. Death becomes a midwife to birth. One generation of stars passes away, and the next ignites from its ashes. This endless exchange is how the Milky Way renews itself, a vast unending chain of inheritance. The evidence of these cycles surrounds us. When astronomers map the galaxy in X-rays and radio waves, they see shells and remnants, ghostly circles where supernovae once flared. The Crab Nebula, still expanding from a blast witnessed on Earth in 1054, glows in tangled filaments of pink and blue. The Vela remnant ripples like a torn veil, its gas still moving outward after 11,000 years. Each of these remnants is a nursery awaiting the ashes of one generation, feeding the birth of the next. It's easy to think of destruction as an ending, but in the Milky Way it is more like respiration. The galaxy inhales, gas forms stars, and exhales heavy elements back into space. Everything that shines and everything that lives depends on this breath. If you could speed up time and watch the galaxy's history unfold, it would look like a forest of light stars blooming, burning and scattering their seeds into the void. Every few seconds, somewhere in the Milky Way, another massive star reaches its end, enriching its surroundings with the raw materials of future planets and beings yet to be imagined. The next time you see the glint of gold or breathe the air of a new morning, remember that you're not separate from that process. You are a result of it. The atoms that make you were once flung into space by an explosion brighter than imagination, and it took billions of years for them to come together again in this particular shape in this particular moment. We are the quiet continuation of stellar death. The Milky Way's long story of cycles of collapse and creation of endings that give rise to beginnings lives inside us. And when our own sun eventually dies, its ashes too will drift back into the interstellar sea, joining that eternal exchange. From them, someday new stars will form, new worlds will awaken, and perhaps under another sky someone else will look up and wonder where they came from, never knowing they are built from the dust of us. Between the bright stars and glowing arms of the Milky Way drifts something almost invisible, thin, dark, and easily overlooked. It is not the emptiness we imagine when we think of space, but a soft presence, interstellar dust, fine grains of carbon and silicate that float in clouds light years wide. These tiny particles, smaller than smoke, obscure much of the galaxy's light, hiding its heart from our eyes. Yet without them, there would be no stars, no planets, no us. To the naked eye, dust seems like absence of veil that dims the stars. Through telescopes, it reveals itself as shadowy lanes across the Milky Way's band, the dark streaks you can see on a clear night. These are not gaps in the galaxy, but rivers of richness, cold clouds where gas and dust collect, cool, and slowly condense into the seeds of stars. In these obscured regions, light struggles to escape. They are the hidden wombs of creation, where new suns and their worlds take form behind curtains of blackness. For centuries, astronomers could only guess what lay inside. Optical telescopes could not pierce the shroud. The galaxy's true structure, its bar, its spiral, its nurseries, was invisible behind those murky veils. Then came the infrared revolution. Instruments that could detect longer wavelengths of light beyond red, where dust becomes transparent, opened the curtains. With the Spitzer Space Telescope, the Herschel Observatory, and now the James Webb Space Telescope, the Milky Way's dark lanes have come alive. Where visible light shows shadow, infrared reveals abundant glowing cocoons, swirling filaments, and clusters of newborn stars still swaddled in dust. The opaque becomes luminous. The same substance that hides creation also protects it, shielding fragile new suns from harsh radiation until they are ready to shine. Through these lenses, we've seen wonders once unimaginable. The Eagle Nebula's pillars, towering columns sculpted from dust by starlight. The Orion Molecular Cloud, where protostars sparkle like embers through fog. The Tarantula Nebula, a storm of light and shadow where dust and radiation wrestle for balance. Each image reminds us that what looks like darkness is often a disguise for becoming. Dust is more than the residue of stars, it is their heirloom. Every grain carries atoms forged in the hearts of older suns, scattered across space by supernovae and stellar winds. carbon, oxygen, iron, silicon, the ingredients of rock air and living flesh. These particles drift for eons, gathering in clouds until gravity gathers them again, forming new stars and planets. Each generation inherits the ashes of the last. The galaxy, like a tree, grows from its own fallen leaves. Even now, the dust between the stars carries organic molecules, simple chains of carbon and hydrogen that are the precursors of life. They form on the surfaces of dust grains in the cold, dark clouds where they are sheltered from radiation. Some are frozen in ices that cling to these microscopic seeds. When such dust becomes part of a forming planet, those molecules survive the journey, locked inside comets and asteroids that may later deliver them to young worlds. In that sense, interstellar dust is not just debris, it is potential the galaxy's memory of creation written in matter. What drifts unseen between the stars may one day breathe, think, or dream. The atoms in your body were once part of that wandering dust, perhaps carried across thousands of light years before finding home in a small blue world orbiting an ordinary sun. To watch the Milky Way through infrared eyes is to watch reincarnation at a cosmic scale. The same particles that dim starlight are the same that will one day form new light. Death and birth trade places in endless rhythm. A dying star enriches the medium with dust. That dust becomes a nebula. The nebula forms new suns. The suns forge new elements and return them again to the void. The darkness you see in the Milky Way's band is not emptiness, it's potential, waiting to shine. So the next time you see that hazy stripe across the night, remember that much of its beauty is hidden. Behind the faint glow lies a billion invisible worlds in preparation, still sculpting themselves from dust. And perhaps in one of those unseen cradles, the first molecules of a distant consciousness are forming tiny threads in the same cosmic fabric that once wove you. We are all children of starlight, yes, but also of shadow. The dust that hides the stars is the dust that makes them, and every motor drift between the constellations carries quietly the promise of life. If you could silence every sound on Earth, every ocean wave, every heartbeat, every whisper of wind, you would still not find quiet. Because above and around you the galaxy is singing, not in notes or melodies, but in frequencies of light that the human ear can never hear. The Milky Way hums across the spectrum, a cosmic symphony of invisible energy layered and ceaseless. What we see as a soft band of starlight is only one instrument in an orchestra that plays in radio-infrared X-rays and gamma rays all at once. To our eyes, the night is still, but to our telescopes it trembles with song. At the lowest notes there is the deep bass of radio waves, long and gentle. These waves stretch across light years, rippling from cold hydrogen clouds, from pulsars spinning like cosmic lighthouses, and from the steady whispers of background radiation, the fading echo of the Big Bang itself. If you could translate radio light into sound, it would be a low, patient murmur like wind through an endless forest. Then come the infrared tones, the warmth between the stars. They emanate from dust and molecular clouds, from star nurseries glowing softly in their cradles. This is the breath of the galaxy's middle age, the warmth that hides beneath darkness. Through the James Webb Space Telescope we see these unseen fires, like embers beneath ash, cool, steady, nurturing. In the higher ranges, the X-rays begin their piercing cry. These are the voices of catastrophe, the searing emissions from collapsed stars, black holes devouring their companions, and gas heated to millions of degrees as it falls inward. In those wavelengths, the galaxy looks alive with motion-hot threads winding around the core flares from binary systems, and arcs of radiation marking the edges of violent histories. And beyond even that, the gamma rays, the highest, most dangerous notes of all. They are born from supernovae, from the collision of neutron stars, from cosmic rays crashing into atoms at near light speed. To us they are invisible, but if eyes could see their glow, the night sky would shimmer with ghostly fountains like silent fireworks over the spiral arms. Two vast plumes of gamma radiation, the Fermi bubbles, rise above and below the Milky Way's core remnants of some long-ago outburst. They still hum faintly in the galactic night, the memory of a heartbeat that once thundered. Together, these forms of light create a lullaby of energy, a song of motion, death, and renewal. Every frequency tells a different part of the story. The radio murmurs of creation, the infrared warmth of life, the X-ray flares of destruction, the gamma whispers of history's deepest scars. The galaxy does not rest. Even when no star is exploding, no comet crossing, no planet forming, the Milky Way's body vibrates with radiation, the background murmur of existence, High-energy particles called cosmic rays fly through space and through you every second. They were born in the hearts of ancient supernovae and travel across thousands of light years, brushing through your atoms like invisible wind. You're never untouched by the galaxy's breath. If you could somehow tune your senses to see all wavelengths at once, the Milky Way would appear not as a quiet spiral, but as a storm of colour and motion threads of gold and blue rivers of red and violet bubbles of furious white where stars have died. The night sky would no longer seem silent but alive, an orchestra of light playing across the fabric of space. And yet, despite all that power, there is a strange gentleness to it. Most of these energies pass through us harmlessly. They are too faint to burn, too diffuse to harm. Instead, they wash over us like a cosmic lullaby, an ancient rhythm that has played since before our world existed. Every moment your body is crossed by the light of dead stars, the echo of the Big Bang and the quiet radiation of your own galaxy's heart. You are immersed in it always, whether you look up or not. The Milky Way does not merely surround you, it sings through you. So as you drift towards sleep, imagine yourself floating in that unseen ocean of light, hearing the faint pulse of the galaxy's energy, the bass of radio waves, the shimmer of X-rays, the hiss of gamma rays, all blending into one vast slow harmony. It is not silence that fills the night sky. It is the oldest song you'll ever hear, a lullaby of invisible light. High above and below the heart of the Milky Way, there hang two ghostly lanterns in the dark, vast, shimmering lobes of high-energy light that stretch for tens of thousands of light years into the halo. They are invisible to human eyes, but to instruments tuned to gamma rays, they blaze like twin auroras frozen in time. Astronomers call them the Fermi bubbles, after the space telescope that first mapped their shape in 2010. Each bubble is enormous, spanning nearly half the galaxy's visible height, and filled with gas and charged particles moving at millions of kilometers per hour. They seem to billow outward from the galactic center, perfectly symmetric above and below the plane like smoke still rising from an ancient fire. And that is perhaps what they are, the scars of a past eruption, a wound from when our galaxy's sleeping heart once burned like a quasar. Today, the black hole at the center, Sagittarius A, rests in relative quiet, sipping slowly on the gas that drifts near it. But there are signs that long ago it was far more ravenous. The evidence lies in these twin plumes of radiation. Some models suggest they were created when the black hole gorged on a surge of matter, igniting in a brilliant outburst that poured jets of energy outward along its poles. For a brief epoch, millions of years ago, the Milky Way may have shone across intergalactic space as a beacon, its core blazing brighter than all its stars combined. Others think the bubbles were inflated not by the black hole, but by a storm of starburst activity, an era when clusters of massive young stars formed, lived and died in rapid succession near the core. Their combined supernovae would have released torrents of gas and radiation, driving winds upward and downward through the galaxy's thick disk. In this view, the bubbles are not a single explosion's echo, but the slow exhalation of a galaxy out of breath. Whatever their origin, the Fermi bubbles are testimony records of violence now long cooled. Their edges glow faintly where the hot plasma collides with the surrounding halo, forming shock fronts that still ripple outward. Inside, the gas is thin but scorching heated to millions of degrees. Through them stream cosmic rays, high-energy messengers from that forgotten chapter, spreading faint gamma radiation that instruments on Earth still detect today. Imagine standing outside the galaxy and looking back at it as though it were an ancient tree. The spiral arms would be the living branches full of leaves and light, but rising from the trunk above and below, you would see two great scars, smooth and darkened with age. They tell you that once lightning struck here, fire climbed the core, split the bark and left behind marks that will fade only after eons. The Fermi bubbles are those scars, quiet records of past ferocity, preserved in the shape of light itself. Their sheer scale reshapes how we think about our home. We tend to picture the Milky Way as a flat disk, serene and balanced, but these towering lobes remind us that galaxies breathe upward and downward, not just outward. Energy flows vertically through the galactic ecosystem like sap through the veins of a tree connecting the core to the halo. Even in apparent stillness, the galaxy remembers motion outbursts that changed its chemistry, stirred its dust, and may even have seeded new stars far from the plane. As the bubbles slowly fade, they reveal an older, quieter phase, what astronomers call galactic senescence, when the most violent processes settle into memory. The glow we detect today is a fading afterimage, the last shimmer of a past brilliance. Millions of years from now, they may be gone, absorbed back into the halo's soft haze. But for now, when we map the sky in gamma rays, we are seeing a diary written in radiation, a record of the Milky Way's temper. It has known fury and silence, creation and collapse. And like the rings of a tree, those twin bubbles stand as evidence that even galaxies age, flare and heal. The night above us seems calm, but the heavens bear their history. Every scar of light tells us that our galaxy too once burned bright enough to change itself. High above and below the heart of the Milky Way, there hang two ghostly lanterns in the dark, vast, shimmering lobes of high-energy light that stretch for tens of thousands of light years into the halo. They are invisible to human eyes, but to instruments tuned to gamma rays, they blaze like twin auroras frozen in time. Astronomers call them the Fermi bubbles, after the space telescope that first mapped their shape in 2010. Each bubble is enormous, spanning nearly half the galaxy's visible height and filled with gas and charged particles moving at millions of kilometers per hour. They seem to billow outward from the galactic center, perfectly symmetric above and below the plane, like smoke still rising from an ancient fire. And that is perhaps what they are, the scars of a past eruption, a wound from when our galaxy's sleeping heart once burned like a quasar. Today, the black hole at the center, Sagittarius A, rests in relative quiet, sipping slowly on the gas that drifts near it. But there are signs that long ago it was far more ravenous. The evidence lies in these twin plumes of radiation. Some models suggest they were created when the black hole gorged on a surge of matter, igniting in a brilliant outburst that poured jets of energy outward along its poles. For a brief epoch millions of years ago, the Milky Way may have shone across intergalactic space, as a beacon, its core blazing brighter than all its stars combined. Others think the bubbles were inflated not by the black hole, but by a storm of starburst activity, an era when clusters of massive young stars formed, lived and died in rapid succession near the core. Their combined supernovae would have released torrents of gas and radiation, driving winds upward and downward through the galaxy's thick disk. In this view, the bubbles are not a single explosion's echo, but the slow exhalation of a galaxy out of breath. Whatever their origin, the Fermi bubbles are testimony records of violence now long cooled. Their edges glow faintly where the hot plasma collides with the surrounding halo, forming shock fronts that still ripple outward. Inside, the gas is thin but scorching, heated to millions of degrees. Through them stream cosmic rays, high-energy messengers from that forgotten chapter, spreading faint gamma radiation that instruments on Earth still detect today. Imagine standing outside the galaxy and looking back at it as though it were an ancient tree. The spiral arms would be the living branches full of leaves and light. But rising from the trunk above and below, you would see two great scars, smooth and darkened with age. They tell you that once lightning struck here. Fire climbed the core, split the bark and left behind marks that will fade only after eons. The Fermi bubbles are those scars, quiet records of past ferocity preserved in the shape of light itself. Their sheer scale reshapes how we think about our home. We tend to picture the Milky Way as a flat disk, serene and balanced. But these towering lobes remind us that galaxies breathe upward and downward, not just outward. Energy flows vertically through the galactic ecosystem like sap through the veins of a tree, connecting the core to the halo. Even in apparent stillness, the galaxy remembers motion outbursts that changed its chemistry, stirred its dust, and may even have seeded new stars far from the plane. As the bubbles slowly fade, they reveal an older, quieter phase, what astronomers call galactic senescence, when the most violent processes settle into memory. The glow we detect today is a fading afterimage, the last shimmer of a past brilliance. Millions of years from now, they may be gone, absorbed back into the halo's soft haze. But for now, when we map the sky in gamma rays, we're seeing a diary written in radiation, a record of the Milky Way's temper. It has known fury and silence, creation and collapse, and like the rings of a tree, those twin bubbles stand as evidence that even galaxies age, flare and heal. The night above us seems calm, but the heavens bear their history. Every scar of light tells us that our galaxy too once burned bright enough to change itself. Between two of the Milky Way's grand spiral arms, Sagittarius to one side and Perseus to the other, there lies a smaller, quieter path. It is not a major highway of stars, but a side road, a cosmic cul-de-sac gently curving through the galaxy's middle distance. Astronomers call it the Orion Spur, and it is here in this peaceful lane of light that our Sun and all its planets reside. If the Milky Way were a city, the Orion Spur would be a suburban street, bright enough to see the skyline, far enough to sleep without hearing the noise. The great arms roar with activity, supernovae bursting, massive stars being born, magnetic fields tangling through clouds of dust. But here between them, the density of stars is lower, the pace is slower, space feels wide and safe. Our Sun's neighborhood stretches for thousands of light years. Around it drift small clusters, gentle nebulae, and calm clouds of interstellar gas. One of these is the local bubble, a cavity carved long ago by ancient supernovae that cleared the surrounding space of dense gas. Within this bubble, our solar system floats in a pocket of relative tranquility, its edges still faintly glowing from interactions with the galaxy's interstellar medium. It is quite literally a region of calm carved out by past storms. This quietude may have saved us. In denser regions where massive stars live and die quickly, planets face constant bombardment from radiation and shockwaves. A world like Earth might never have had time to cool, to stabilize, to grow oceans and forests before being stripped bare again. But here in the Orion Spur, supernovae are distant enough to light the sky without ending it. The cosmic weather is mild, the intervals between disasters are long. Life once sparked can unfold in peace. When astronomers map our galactic position, they find that the Sun sits roughly 27,000 light-years from the Milky Way's center, far enough to avoid the turmoil of the core, close enough to remain within the galaxy's habitable belt. Our orbit traces the inside edge of this spur, moving at over 220 kilometers per second. Yet the distances are so vast that our place feels almost still. Every 225 million years, we complete one galactic year, one slow turn around the Milky Way's heart. Since the dawn of life, we've made only about 20 laps. If you look up on a clear dark night and trace the hazy band of the Milky Way across the sky, you are looking along this lane. The constellations Orion, Perseus, and Sagittarius mark its borders like street signs in the dark. The Orion Nebula itself, visible as a faint smudge in Orion's sword, is one of the closest stellar nurseries to Earth, a reminder that even in this quiet district, creation never fully stops. It is humbling to realize that this unassuming region, neither too bright nor too barren, is where the universe found room for us. Out of billions of possibilities, we orbit a stable star in a calm corridor, between violent centers and silent outskirts. This modest setting has given our planet 4.5 billion years of grace time, enough for mountains to rise and fall, for civilizations to be born, for minds to wonder about the sky they see. Perhaps that is why the Orion Spur feels so fitting a home. It is not a place of grand spectacle, but of balance. Here we are, close enough to witness the galaxy's beauty, yet far enough to survive it. The light of nearby stars travels through clear, low-density space, reaching us unbroken. Our Sun's radiation escapes easily into the void, letting Earth remain warm but not scorched. The entire neighborhood seems tuned delicately to the frequency of life. In a way, we are the children of compromise, the beneficiaries of this quiet address between the chaos of the arms. Every sunrise on Earth, every orbit of the Moon happens inside this calm bubble, drifting through the Milky Way's spiral. While supernovae flare in the distance and black holes spin in darkness, our little spur glides on serene like a boat in the lee of a great storm. And maybe that's why the night sky feels comforting rather than terrifying. Because we live in the quiet lane of a restless galaxy. A peaceful, unhurried corner where stars hum softly, planets circle in calm rhythm, and one small world has time to dream about the vastness that surrounds it. Our galaxy does not wander alone through the void. Though the Milky Way appears solitary when seen from Earth, a self-contained spiral adrift in the darkness, it is in truth part of a small cosmic family known as the Local Group. This gathering of more than 50 galaxies drifts together through intergalactic space, bound not by proximity or affection, but by the invisible grip of gravity, a kind of unspoken kinship written in motion rather than words. At the center of this quiet cluster are two great spirals, the Milky Way and Andromeda, each with its own retinue of smaller companions. Around them swarm dwarf galaxies, tiny irregular clouds of stars like satellites circling giants. The large and small Magellanic clouds trail behind us in the southern sky, luminous smudges easily visible from Earth's darker latitudes. They're our nearest cousins, tugging at the Milky Way's outer disk, feeding its streams of gas and stirring its structure with their gravitational pull. Farther away, Andromeda commands its own court, the triangulum galaxy M33, and a halo of dim ancient dwarfs orbiting in silence. Together, these systems form a loose drifting cluster about 10 million light-years across. Unlike the crowded, violent clusters elsewhere in the universe, the local group is a quiet neighborhood. Its galaxies move slowly, circling and approaching one another with the patience of continents. There are no titanic collisions, yet no chaos of dozens of giants merging in blinding light. Instead, there is anticipation, a calm before a meeting that will take billions of years to unfold. Andromeda and the Milky Way are on a slow-motion collision course, their fates intertwined, their future offspring already written in gravitational mathematics. But for now, there is peace. Between these galaxies lies the intergalactic medium, a sparse sea of gas so thin that a single cubic meter might contain only a few atoms. Across that gulf, faint bridges of hydrogen connect our galaxy to its companions, tidal threads stretched by ancient interactions. It's a family held together not by closeness, but by unseen tension, each member tugging softly on the others, each orbit subtly altered by the collective mass of the rest. If you could zoom out far enough to see them all at once, the local group would resemble an island chain suspended in darkness. Two bright spirals at the center, surrounded by smaller, dimmer outposts, each galaxy an independent story yet sharing a common history. Some are fading relics stripped of gas and nearly silent. Others still pulse with star formation, blue and alive. Each one adds its own voice to the quiet chorus of light that defines our corner of the universe. And in that there is something profoundly human. Families too are collections of orbits, distant, imperfect, yet connected. We drift apart sometimes for lifetimes, but invisible ties remain gravity of memory pull of shared origin. The local group is like that. Its galaxies may be separated by millions of light years, yet they are bound to one another, as surely as planets are to stars. They share a gravitational lineage, a web of cause and effect, that ensures their paths will always curve together, however far they roam. Our own Milky Way is not the eldest or the brightest, but it plays a central role in this cosmic kin. Over the next few billion years, its dance with Andromeda will reshape both galaxies, merging their stars into a single vast elliptical form. The smaller members, the dwarfs, the clouds, will fall inward, absorbed into the new creation. What began as a scattered family will end as a single, luminous being, one galaxy born from many, the local group's quiet reunion written in light. For now, though, we live between those future embraces. We spin gently in our lane of the Orion Spur, while far beyond our vision, our sister galaxy draws nearer by a few hundred kilometers each second. The distance is still immense, but the motion is inevitable. We are part of something larger than ourselves, carried forward not by will, but by belonging. When you look up at the Milky Way, you're not just seeing your own home, you're seeing one member of a galactic family still finding its shape. Across the dark, the others shine faintly back, and in their silent drift, there's a truth we share with them that connection need not mean closeness. Sometimes it is enough simply to move through the same darkness, drawn by the same unseen pull. Every spiral of light in the Milky Way is traced not only by stars and gas, but by something unseen, a hidden architecture of magnetism threading through the galaxy like invisible embroidery in starlight. You can't see it, and yet it shapes almost everything, the way dust drifts, the way gas collapses, the way cosmic rays wander through the dark. The Milky Way's magnetic field is faint millions of times weaker than the magnet on your refrigerator, but across tens of thousands of light years its influence is immense. It threads through the galactic disk, looping upward into the halo, bending with the spiral arms and twisting into long filaments that bridge clouds of dust and plasma. It is a net woven from invisible lines holding the galaxy's interstellar medium in quiet tension. Astronomers have only begun to see it clearly. By studying polarized light, the subtle alignment of electromagnetic waves as they pass through magnetic fields, we can trace its patterns like brushstrokes in the dark. Radio telescopes reveal great arcs where magnetic forces shape the flow of cosmic material. Infrared observations show dust grains aligning themselves along these unseen lines, turning space into a luminous tapestry where every thread tells a story of direction and motion. It's as though the galaxy were an enormous loom spinning threads of gas and energy into the fabric of its being. In some places the weave is tight and orderly, magnetic fields running parallel to the spiral arms, guiding the movement of charged particles, and helping to compress gas into ribbons where stars can form. In others, the threads are tangled, twisted by the shock waves of supernovae and the turbulence of stellar winds. These chaotic knots can trap cosmic rays for millions of years, bouncing them through magnetic mazes until they finally escape into intergalactic space. Even cosmic dust, tiny grains of carbon and silicate, dances to this silent rhythm. Spinning rapidly, each grain acts like a microscopic compass needle aligning itself with the local field. The starlight that passes through these aligned grains becomes faintly polarized, a delicate signature of the galaxy's magnetic handwriting. With enough precision, astronomers can read that handwriting, mapping the curvature of the field, the way a sailor reads wind on the water. The galactic field isn't static. It breathes and flexes with time, stirred by dynamo processes in the rotating disk. As plasma moves through the galaxy, it generates electric currents that strengthen and sustain the field, like a heart beating invisibly within the Milky Way's vast body. These magnetic tides help regulate how gas condenses, how stars are born, and even how matter and energy escape into the halo. Without them, the galaxy would be looser, more chaotic, perhaps unable to sustain the graceful structure we see. Think of it as cosmic embroidery, each filament of force, a thread connecting stars and clouds in a pattern too grand for human sight. If our eyes could see magnetism instead of light, the sky would glow with swirling geometry loops rising from the galactic plane tendrils curling toward the poles, luminous whirls where supernova remnants twist the fabric. It would look alive, pulsing with invisible current. This magnetic network doesn't end at the edge of the Milky Way. It extends outward, merging with the intergalactic fields that link galaxies together, a cosmic web of energy spanning the universe. Even between galaxies in what we call emptiness, these faint threads persist, binding everything into one continuous design. And here on Earth, that same galactic field touches us. The cosmic rays that stream through our atmosphere are guided by its shape. The auroras that shimmer at the poles are the visible whispers of its presence. When you watch those lights dance across the sky, you're watching the galaxy's magnetic breath ripple through the edge of our world. We often picture the Milky Way as a grand whirl of stars, but beneath that visible beauty lies something more delicate, a structure of order and tension, the warp and weft of the cosmic fabric. Magnetism is its quiet weaver, shaping without being seen, holding without being held. If starlight is the galaxy's voice, then magnetism is its touch, gentle, invisible, and everywhere at once. And though we cannot see its threads, we are stitched into them, part of the same vast pattern that binds dust stars and dreams together in one luminous weave. Out beyond the spiral arms in the dim expanse of the Milky Way's halo, there wander worlds without suns. They drift in silence unseen, except when they briefly betray themselves by bending a star's light. These are the rogue planets, wanderers untethered to any star set adrift in interstellar space. There may be billions of them, perhaps more numerous than the stars themselves. Each began its life anchored to a sun, orbiting like our Earth does until something tore it loose. A passing giant planet, a collision, a close encounter with another star, one sharp gravitational tug was enough to fling it outward forever. Now these orphans roam through the cold, like ships whose home port has vanished. You might imagine such a planet as dead, frozen, airless, lifeless. But nature is often more inventive than we assume. Even without sunlight, a rogue world might still harbour warmth deep within. As its rocky core flexes and grinds under the relic heat of its formation, or from the decay of radioactive elements, it can sustain internal fires for billions of years. Beneath thick layers of ice, such a planet could hide a subsurface ocean, dark, pressurized, and quietly alive. Some of these worlds might still wear atmospheres that refuse to escape. Hydrogen, the lightest gas of all, can linger if gravity is strong enough and the air thick enough. A dense hydrogen envelope could trap geothermal heat, like a blanket keeping the planet's interior warm long after its star is gone. In that perpetual night, the sky would never brighten, but the air might still shimmer faintly with auroras from cosmic rays, pale green curtains dancing across an endless twilight. Others may be giants, failed stars called brown dwarfs, massive enough to glow faintly from their own internal fusion, but too small to ignite fully. Around these lonely embers, moons could orbit dimly lit by infrared warmth. Such systems are worlds within worlds, miniature solar systems adrift through the galaxy carrying light of their own. Astronomers find these vagabonds through microlensing, when a rogue planet passes in front of a distant star and momentarily magnifies its light. The effect lasts only hours, a cosmic heartbeat, a hint of presence before the planet vanishes again into darkness. It's like glimpsing a traveller by lantern light on a road with no map. For each one, we've seen countless others slip by unnoticed, cloaked in silence. Imagine standing on one of those worlds. There would be no sunrise, no shadows, no sense of direction. The sky would be perfectly black, punctured only by distant galaxies and the faint smear of the Milky Way. Yet underfoot the ground might still be warm. Volcanic plumes could rise through cracks in the ice. A slow rain of frozen methane might fall from a low, thick sky. If there were oceans, they'd be mirror dark, reflecting only the glow of the planet's own heat. Could life exist there? Perhaps, though, it would not resemble anything we know. Microbes feeding on chemical energy rather than sunlight might thrive near geothermal vents much as they do in the black depths of Earth's oceans. Life on a rogue planet would never see a sky, or a star never know day or night. It would live by the pulse of the planet's own hidden warmth, a flame kept alive in the coldest dark. Even in their solitude, these worlds belong to the Milky Way's great story. Some may drift for billions of years before being captured again by a passing star slipping quietly into orbit around a new sun. Others will roam forever silent witnesses to the galaxy's changing face. They are the drifters of the cosmos, proof that even when gravity breaks its bonds, motion continues and existence finds new equilibrium in the dark. When we think of the galaxy, we imagine light stars, clusters, glowing arms, but most of it is shadow, and within that shadow these lonely worlds drift. They are the slow heartbeat of the Milky Way's wilderness, reminders that home can be lost and still carried within that warmth can survive even without a star. Somewhere in the darkness between galaxies, a planet spins unseen, its oceans murmuring beneath miles of ice, its core whispering with heat. No sunrise will ever touch it, but it endures a small, stubborn ember floating through eternity. Across the quiet darkness between the stars drifts something older than planets, older than sun's dust, but not the kind that settles on shelves or hides beneath furniture. This dust is alive with possibility. Each grain, no larger than smoke, carries a chemistry so intricate that it blurs the line between inanimate and alive. Within these drifting motes, the galaxy keeps its seeds. In the vast molecular clouds that thread through the Milky Way, ultraviolet light cosmic rays and cold collisions weave atoms into ever more complex forms. Carbon binds with hydrogen, oxygen, and nitrogen to form alcohols, formaldehydes, sugars, and amino precursors. Simple rings of carbon stack into polycyclic aromatic hydrocarbons molecules so stable and abundant that they may account for 1/10 of all carbon in the universe. Some form icy mantles around grains of silicate dust, freezing chemistry into microscopic archives. In these clouds, temperatures drop to just a few degrees above absolute zero. There is no sunlight, no warmth, only time. Millions of years for molecules to combine, break apart, and recombine again. Radiation acts like a slow sculptor, turning chaos into order, randomness into recipe. When the clouds eventually collapse to form stars, they carry with them these molecular treasures. The same dust that dims the Milky Way's light becomes the soil of new worlds. Every planet, every comet, every moon begins with this inheritance. Even Earth's earliest oceans were likely seeded by comets and asteroids rich in organic molecules, fragments of interstellar chemistry older than the solar system itself. When we study meteorites that have fallen from space, we find amino acids, hydrocarbons, and sugars embedded within. These are messages from the molecular dawn, written long before our planet formed. Some scientists call this idea panspermia, that life, or at least its ingredients, may travel between worlds. Not as organisms with wings or spores, but as microscopic passengers on dust grains, comets, and rocks. When a planet is struck by an asteroid, fragments can be blasted into space, carrying organic material that might someday fall onto another world. Over billions of years, these exchanges could scatter the ingredients of life across the galaxy, making biology not an isolated accident, but a shared inheritance. It's a poetic thought that the galaxy itself is a gardener sowing carbon seeds wherever gravity shapes new soil. Star nurseries become greenhouses of chemistry. Supernovae act as compost, spreading the elements. Comets and meteors become couriers of molecular potential. Life in this view is not something that begins and ends, it migrates, transforms, and blooms wherever the conditions allow. Perhaps somewhere in the spiral arms on a quiet world, orbiting a modest star molecules from a cloud, billions of years old have begun again to stir. They align, fold, react, and suddenly there is motion replication memory. The dust has remembered how to dream. When you breathe, when you touch another living being, you are touching that same ancient chemistry. The carbon in your skin once drifted in a cold cloud near the galaxy's rim. The oxygen in your lungs was forged in a dying star. The nitrogen in your DNA was carried by comets that fell before the first dawn. The galaxy has been practicing life for a very long time. The Milky Way is more than a machine of gravity, it is a living laboratory. It stirs, mixes, and refines matter across billions of years until eventually somewhere consciousness opens its eyes and looks back at the stars that made it. We are that moment, the galaxy's self-awareness, fleeting and fragile yet inevitable as light. So when you look up at the night sky, don't just see stars. See the gardens between them, the invisible orchards of carbon dust drifting through the dark, waiting patiently for warmth, water, and time. They are the seeds of everything, of oceans of thought, of love itself. The galaxy, like a gardener, scatters freely and trusts that somewhere, somehow, a seed will take root. And here we are, proof that it does. Every second of every night, something extraordinary passes through you. It does not touch your skin or disturb your sleep, yet it moves through every atom of your body, every grain of air, every line of starlight crossing the room. Space itself is trembling so softly that we cannot feel it so steadily that the universe seems to breathe. These tremors are gravitational waves, ripples in the very fabric of space-time. They spread outward whenever something massive moves with great violence. Two black holes colliding, a pair of neutron stars spiraling together, the collapse of a dying sun. When such titans meet, they send shivers through the cosmos, and those shivers never stop. They pass through galaxies, stars, and sleeping worlds alike, stretching and compressing space itself by less than the width of a proton. Yet across billions of light years they endure. You are living inside an ocean you cannot see. Space is not still, it flexes gently, endlessly. When gravitational waves roll through the distance between atoms, changes imperceptibly, like a breath too slow to notice. Every star, every planet, every cell participates in this cosmic respiration. The universe expands and contracts, exhales and inhales, and we oblivious passengers float upon that invisible tide. Astronomers learned to hear these whispers only recently. In 2015, the LIGO observatories in the United States caught the faintest possible echo, two black holes merging a billion light-years away. The signal lasted just a fraction of a second, but it was unmistakable, a rising tone like the last note of a cosmic bell. Space had rung, and we had heard it. Since then, more such ripples have been detected, each one a story from an event that ended long before Earth's first creatures took their first steps. Alongside these waves come even swifter messengers, neutrinos, ghost-like particles born in nuclear reactions within stars and supernovae. Trillions of them stream through your body every second, passing through walls, oceans, and entire planets as though they were not there. They are almost without mass, almost without interaction, yet they carry information from the hearts of stars. In a sense, every second you are brushed by the breath of the galaxy, the faint radiation of all that burns and dies in its depths. If you could slow down time and make these invisible phenomena visible, the world would look like a gentle sea. Space itself would undulate in vast, slow waves, its surface rising and falling by impossibly small degrees. Through it would drift endless streams of neutrinos like shafts of light through deep water. Every object, the Earth, the Moon, the atoms in your bones would sway ever so slightly, synchronized to a rhythm older than light itself. There is something deeply comforting in this knowledge. We often think of the universe as cold and distant, but these waves remind us that it is alive with motion. The same space that holds you tonight is quivering with the echoes of ancient collisions. The same emptiness you gaze into is filled with invisible music vibrations that weave together every corner of creation. As you lie still beneath the night sky, the galaxy's quiet pulse passes through you. It does not ask for your attention. It simply continues, steady, impartial, eternal. You are part of that rhythm, part of the same continuity that joins the hearts of dying stars to the atoms in your chest. So breathe with the universe. Let the thought settle that while you sleep, space itself is moving through you, reshaping distances by the faintest touch. You are adrift in a sea of gravity and light rocked by waves that have traveled for billions of years to find you. and somewhere far beyond the reach of your senses, two black holes spiral closer, ready to send another ripple across this boundless ocean. In time, that wave will reach Earth, will pass through. Your room will stretch and compress everything you know, so gently you'll never notice. But it will be there, part of the same cosmic lullaby that hums beneath all things space-breathing stars, speaking, and you asleep, carried upon the calmest tide in existence. For most of human history, the Milky Way was a mystery painted across the night. We saw its glow, but not its shape. We sensed its enormity, but could not measure its depths. We were wanderers who knew we lived somewhere in the galaxy, but not where. And then, across a few short decades that changed, humanity built eyes precise enough to chart the heavens themselves. We became at last the map makers of the galaxy. At the heart of this transformation is Gaia, a spacecraft launched by the European Space Agency in 2013. From its vantage point a million miles from Earth, it turns slowly, scanning the sky with exquisite patience. Every star it observes is measured and remeasured, its position, brightness, motion, and parallax recorded with astonishing accuracy. Gaia doesn't just photograph the Milky Way, it builds it, point by point, transforming starlight into coordinates and coordinates into understanding. To map a galaxy is to measure motion itself. The Earth spins around the Sun orbits the Milky Way, and the galaxy drifts through the universe all at once. Gaia accounts for all of it. Its instruments can detect shifts in a star's position as small as the width of a coin seen from the moon. Over time, those measurements reveal each star's journey, how it moves through the galactic disk, how clusters dissolve, how streams of ancient mergers weave their paths through the halo. It is celestial cartography at a scale no human mind can fully imagine. From its data, astronomers have built a 3D map of over 2 billion stars, a dynamic rotating model of the Milky Way in motion. Every dot in that map represents a sun, perhaps with its own planets, its own stories, its own horizons. Together they form the most complete portrait ever drawn of our home in the cosmos. When we visualize this data set, we see the spiral arms winding the disk, rippling the halo surrounding everything like a faint mist. For the first time, the galaxy has a face, and we know where we stand upon it. The precision of Gaia's measurements is a triumph, not just of engineering, but of collaboration. Thousands of scientists, mathematicians, and engineers across continents contribute to processing its torrent of data. They correct for every wobble, every photon, every subtle bias of the instrument. Each release of Gaia's data is a gift of shared curiosity, a collective act of patience and wonder. It reminds us that mapping the galaxy is not a race or a conquest, but a conversation between human ingenuity and the universe that made it possible. To chart the stars is to remember that we are small but not lost. Knowing our position in the Milky Way is not a gesture of control but of belonging. When you see the sun's location plotted in the Orion spur halfway between the galactic core and the outer rim, you're looking at your address in eternity. Every coordinate, every motion, every pattern of parallax tells you this is where you are in the great turning of all things. It is an act of humility and of hope. We map because we are restless. We measure because we long to understand. And yet each new discovery reminds us how vast the unmapped still remains. Gaia's vision reaches only so far before stars blur into haze, before dust thickens, before distance stretches beyond the reach of even the finest instruments. Beyond that lies mystery again, the uncharted dark that keeps the galaxy alive with wonder. Perhaps that is what makes these maps so moving. They are not just diagrams of matter, but of meaning. They show what happens when a species born on a small planet around an ordinary star decides to lift its gaze and find its place among billions. They're in a quiet way love letters to precision, to curiosity, to everything that glows in the dark. So tonight, when you look up, imagine the invisible grid surrounding you, the coordinates of every star, the paths they trace, the way Gaia watches them drift. You are living inside the greatest map ever made, one still being drawn, line by line, photon by photon. And somewhere in that vast geometry marked by a single dot, among 2 billion others, is the sun, our tiny golden landmark in the spiral sea. We are no longer lost in the Milky Way. We are learning to read its shape, to name its directions, to say, we live here. And that simple knowing, that gentle awareness of where home lies, is one of the finest things our species has ever done. When you look up at a dark, moonless sky, and see that hazy river of light stretching from horizon to horizon, you're gazing from the inside of something so vast that no single view can contain it. That soft band, the Milky Way, looks like a stripe across the heavens only because we live inside it. We are trying to glimpse a galaxy from within its own body, like standing deep inside a forest and trying to see the shape of all the trees at once. If we could rise above the galaxy and look down, we would see a great spiral arms curling like smoke around a bright center, the whole disk rotating in slow grace. But from our home on Earth, 2/3 of the way out from that center, our view is trapped along the plane. We look sideways through the thickest part of the stellar disk where billions of stars, clouds of gas and trails of dust overlap in layers of light and shadow. What appears to our eyes as a glowing stripe is actually the cross-section of our galaxy seen edge on. It's a trick of perspective, but a beautiful one. The light you see in that band comes from tens of thousands of light years away, overlapping into a luminous mist. Within it are every kind of star imaginable, young blue giants, blazing in clusters, ancient red dwarfs glowing faintly in solitude, and dark lanes of dust that swallow starlight like ink across paper. Those dark streaks are not empty space. They are the veins of the galaxy, dense clouds, where new stars are quietly forming hidden from view. Astronomers sometimes say that we are astronomically parochial, locked inside our local neighborhood, unable to step outside for a wider look. Even the most powerful telescopes can only reconstruct the Milky Way's full form indirectly, by measuring distances, velocities and brightness across the sky. It's as though we are blindfolded inside a vast cathedral, mapping its structure by listening to echoes. Yet those echoes collected from radio infrared and X-ray light have given us a near-complete picture. We now know our galaxy spans about 100,000 light-years with a slender disk, a swollen bulge and spiral arms laced with dust and gas. Still, there is poetry in our limited view. Because we are inside the Milky Way, we see its stars not as a distant object, but as a living canopy above us. We don't just observe it, we dwell within it. Every star in that glowing river is part of our shared neighborhood, every photon a message sent across time to the only vantage point it could ever reach, right here inside the forest of light. Imagine standing at night amid towering trees. You cannot see their shape from above, but you can feel the rhythm of the trunks, the pattern of their shadows, the way the branches weave into a single, living whole. That's how it is for us in the galaxy. The Milky Way surrounds us on every side, its light filtering through layers of cosmic leaves. We are too close to see its full silhouette, but close enough to sense its heartbeat. And perhaps that's fitting. The galaxy was never meant to be an image seen from afar, it was meant to be a place lived within. Its beauty lies in perspective, in how we catch glimpses of its vastness through the narrow window of our own sky. The strip of light we call the Milky Way is not a boundary. It is a reminder that we are inside something immense, a participant in the pattern rather than a spectator. The next time you see that silvery band arching over the world, think of it not as a distant phenomenon, but as the view from home, the inside-out horizon of a spiral galaxy, turning gently through space. Like someone in a forest at twilight, you cannot see the entire tree, but you can smell the pine, feel the bark beneath your fingers, and know that you are part of the living whole. We are all of us leaves within the Milky Way's forest, and the light above is simply the canopy through which the galaxy lets us dream. At the end of all these spirals, at the edge of all this light, there is stillness. The Milky Way turns endlessly, but here on a small world, orbiting an ordinary star, there is a pause long enough to listen. We have followed its arms and its dust, its invisible threads and drifting planets. We have walked through its magnetic weaves and traced its maps of stars. We have watched it breathe in gravitational waves, sing in invisible light and cradle the seeds of life in clouds of carbon and ice. And now beneath its slow circling glow we can rest in the knowledge that we belong to it all. Every atom in your body once burned in the heart of a star. The iron that carries oxygen through your blood was forged in a supernova. The calcium in your bones was made in the last breaths of a dying sun. The carbon in your skin was formed when the galaxy was still young, carried for billions of years in drifting dust, until the Earth called it home. You are the galaxy remembering itself for a moment as human. The Milky Way is vast beyond words. Hundreds of billions of stars, thousands of clusters, clouds so wide, they take light centuries to cross. And yet from this one small place, consciousness has bloomed. Eyes opened, looked upward and recognized the shape of home. That awareness is not separate from the stars, it is their quiet continuation. The universe does not simply contain life, it becomes life again and again wherever it can. Think of everything you've ever loved, every memory and kindness, every sound that has ever made you pause. All of it is made of stardust that learned to speak and to care. The same forces that sculpted galaxies shaped your heartbeat. The same gravity that binds stars together holds you gently to this turning world. Tonight, as the Earth spins beneath the Milky Way, imagine that slow motion, the galaxy revolving like a vast lantern, its arms folding and unfolding in silence. You are within it, carried effortlessly, part of a pattern too large to fear and too beautiful to fully know. Out there, stars are being born, others are dying. Between them, planets wander, dust drifts and invisible threads hum with light. Through all of it, the same elements repeat their endless dance, fire, carbon, silence, renewal. And here for this moment, you are the still point in that motion. The quiet center of everything you've come from and everything you'll return to. You don't need to travel to touch the galaxy. You're already inside it. Every breath you take is filled with its history. Every heartbeat adds one more rhythm to its music. So let the thoughts settle like starlight on calm water. You are home. You are part of the Milky Way story, one chapter in a book still being written in light. You were born from its dust, sustained by its warmth, and when your own light fades, you'll return to it to be woven again into the fabric of something new. The galaxy will go on spinning, stars will rise and fall, and somewhere life will once again lift its eyes to the same sky and wonder. Until then, breathe softly, let gravity hold you, let the Milky Way turn. You're safe inside its arms, a small luminous thought in a galaxy dreaming of itself. Good night.